The night sky has always whispered secrets to those who dare to look up, but some of those secrets scream defiance at the very laws of physics. Right now, scattered across the cosmos, there are events unfolding that make even the most seasoned scientists pause mid-equation. Flashes of energy with no discernible source, celestial objects behaving in ways that should be impossible, signals from deep space that repeat with frustrating irregularity. These aren't plot points from a sci-fi novel. They're real, documented phenomena that have astronomers rewriting textbooks. What if I told you some of these cosmic puzzles might hold clues to unraveling the fundamental nature of reality itself? Over the next 50 revelations, we'll encounter stellar mysteries that refuse to fit into neat scientific boxes, like the star that flickers as if something colossal is passing in front of it, or the galaxy that rotates as though invisible hands are turning it. Buckle up, we're about to venture into the cosmic unknown where the rules as we know them no longer apply. One summer night in 1977, a radio telescope in Ohio picked up something that defied all expectations, a sudden, intense burst of radio waves so unusual that the astronomer who discovered it scrawled, "Wow." Right on the printout, that single word gave the signal its name, and for good reason. The burst lasted exactly 72 seconds and matched the exact frequency scientists predicted an extraterrestrial transmission might use. But here's the thing, it never repeated. Despite decades of scanning the same patch of sky, no one has ever detected anything like it again. Some researchers argue it could have been a natural cosmic event, maybe a comet's hydrogen cloud or a bizarre stellar phenomenon. Others can't shake the possibility that we caught a fleeting message from another civilization, a whisper in the dark that vanished before we could reply. The WOW signal's mystery only deepens when you consider that the radio frequency it used is naturally quiet, making interference from human-made sources unlikely. So was it a cosmic accident or something far more deliberate? Every now and then, new theories emerge, some suggesting exotic astrophysics, others holding onto the tantalizing idea of intelligent origin. But until we find another signal like it, or perhaps even decode its meaning, the WOW signal remains one of astronomy's greatest unsolved enigmas. It's a reminder that the universe is full of surprises, and sometimes the most extraordinary things only happen once. Imagine the universe as a grand cosmic play. We see the actors, the swirling galaxies and glittering stars, but something crucial is missing. Nearly a third of the entire script is written in invisible ink. That's the puzzle of dark matter, an unseen force that shapes everything around us yet refuses to take a bow. Here's what we know for sure. When astronomers measure how galaxies spin, the outer stars move far too fast for the visible matter alone to hold them together. Without some hidden source of gravity, these galaxies should tear themselves apart. Even more telling when we observe how massive objects bend light in deep space, an effect called gravitational lensing. The distortion is far stronger than the visible mass can explain. The math is undeniable. Something invisible is pulling the strings. Some of the brightest minds in physics have spent decades chasing possible explanations. Could dark matter be made of weakly interacting massive particles that barely touch ordinary matter except through gravity? Or perhaps actions, hypothetical particles so light they'd stream through you like wind through a screen door? Yet despite detectors buried deep underground and experiments in space, not a single one of these particles has been caught in the act. But here's where it gets even stranger. A handful of scientists argue that maybe we're looking at this all wrong. What if dark matter doesn't exist at all, and instead our laws of gravity need a radical rewrite? It wouldn't be the first time physics had to bend. Einstein's relativity shattered Newton's ideas when faced with the cosmos oddities. Yet so far, alternative theories struggle to explain everything we observe as neatly as dark matter does. One thing's certain until we crack this mystery: we're like sailors navigating by stars we can't see, guided by a force that refuses to be named. Whether it's undiscovered particles or a flaw in our cosmic rulebook, the answer won't just solve a puzzle, it could redefine reality itself. Out in the vast blackness between galaxies, cosmic fireworks explode in bursts of radio waves so powerful they outshine entire stars, and they vanish before we can blink. Fast radio bursts, or FRB, are among the most baffling signals the universe has thrown at us. Lasting just milliseconds, a single FRB can unleash as much energy as our sun pumps out over 80 years. That's like a flashbulb brighter than a supernova, flickering on and off before you even realize it's there. The first FRB was detected in 2007, hiding in old telescope data, a blip so strange scientists initially dismissed it as equipment glitch. But then more followed. Some burst once and never repeat, like cosmic one-hit wonders. Others, like FRB 1212, fire off signals in erratic patterns like a drummer with no rhythm. And their origins even wilder. A few trace back to magnetars, super dense, highly magnetic corpses of dead stars prone to violent tantrums. But many others come from regions of space with no obvious source, sparking theories ranging from colliding neutron stars to, well, something far more speculative. Here's the real head-scratcher. In 2020, astronomers found an FRB inside our own Milky Way, finally close enough to study in detail. It did come from a magnetar, suggesting some FRBs could be natural. Yet the distant, repeating bursts still don't fit neatly into that box. Why do some repeat while others vanish forever? Why do their frequencies sometimes dip in ways that defy known physics? The leading theories sound like sci-fi: cosmic strings vibrating through space-time, black holes evaporating into bursts of energy, even whispered signatures of advanced alien propulsion systems. Though most scientists caution that exotic astrophysics is the far likelier culprit, whatever the truth, FRBs are more than just cosmic static. They're telegrams from the universe's most extreme environments, written in a code we're just beginning to crack. And each new detection brings us closer to answers that might shake the foundations of how we understand energy, matter, and the very fabric of the cosmos. Picture this: the Milky Way isn't just drifting through space, it's racing towards something unseen at over 2 million kilometers per hour, and it's not alone. Thousands of galaxies are caught in the same inexplicable current, as if the cosmos has tilted its scales and everything is sliding toward a hidden finish line. Welcome to the mystery of the Great Attractor, a gravitational anomaly so powerful it warps the motion of entire galaxy clusters, yet we can barely see it. Tucked behind the thick dust lanes of our own galaxy's southern hemisphere, this enigmatic force was first detected in the 1970s when astronomers noticed peculiar patterns in galactic motion. The math was clear: something colossal was pulling us toward it, something with the mass of tens of thousands of Milky Ways. But when they looked in that direction, the view was obscured by our galaxy's own cosmic fog. Initial theories suggested it might be an unimaginably dense supercluster of galaxies, hidden from view. Yet later observations revealed the Norma cluster, a massive structure in that region, wasn't nearly heavy enough to explain the pull. This left scientists grappling with even wilder possibilities. Could dark matter be clumped there in unprecedented quantities? Or was Einstein's theory of gravity itself incomplete on such vast scales? The plot thickened with the discovery of the even larger Shapley supercluster lying beyond the Great Attractor. Some argue this more distant structure might be the true puppet master, its gravity influencing everything in between. Others propose the Great Attractor could be a rare intersection of cosmic filaments, a gravitational knot in the universe's web where flows of dark matter converge. What makes this puzzle so gripping is how it challenges our cosmic maps. Modern telescopes like XMM Newton and future projects like the Square Kilometre Array are finally piercing through the Milky Way's dusty veil, revealing hints of strange structures and unexpected motions. Each new observation brings us closer to understanding whether this is a true anomaly in space or an anomaly in our understanding. One thing's certain, the universe seems determined to humble us. Just when we think we've charted the heavens, we find ourselves caught in a current we can't fully explain, racing toward a mystery written in gravity's invisible ink. Most stars shine with steady reliability, their light flickering no more than a candle in a gentle breeze. But in the constellation Cygnus, one star refuses to follow the rules. KIC 8462852, better known as Tabby's star, has been caught in the act of dramatic, unpredictable dimming, dropping in brightness by staggering amounts with no clear explanation. When astronomer Tabetha Boyajian first studied the star's Kepler Space Telescope data in 2015, the readings defied logic. Planets passing in front of stars caused predictable, symmetrical dips in light, but Tabby's star dimmed erratically, sometimes by as much as 22%. That's like something massive and misshapen, far larger than any planet, blocking its light in jagged, uneven patterns. At first, scientists proposed a colossal swarm of comets, but the scale required would be unlike anything we've ever seen. Then came the more provocative theory: could this be evidence of alien megastructures, like hypothetical Dyson spheres designed to harvest a star's energy? But before we jump to extraterrestrial conclusions, recent observations offer a more mundane, though still puzzling, explanation. Detailed studies detected light scattering in ways that suggest vast, swirling dust clouds may be responsible. The catch: even this theory struggles to explain why the dimming happens so asymmetrically, or why historical data shows the star has also been gradually darkening for over a century. The debate continues because Tabby's star doesn't fit neatly into any known cosmic category. Some researchers argue it could be a young star still clearing planetary debris, while others wonder if we're witnessing the aftermath of a rare celestial collision. Even the dust explanation leaves gaps. Why isn't it emitting the infrared heat we'd expect? What makes this star so compelling is how it challenges our assumptions. Whether the answer turns out to be interstellar dust, shattered planets, or something even stranger, Tabby's star reminds us that the universe is still full of surprises. Every new observation adds another twist to the mystery, proving that sometimes the most extraordinary discoveries begin with a single star that simply refuses to behave. The universe is unimaginably vast, with billions of galaxies, each brimming with stars and planets. Given the sheer numbers, the odds seem overwhelming. Life must exist somewhere else. Yet when we listen, all we hear is silence. This glaring contradiction is the Fermi Paradox, a puzzle that has haunted scientists since physicist Enrico Fermi first asked the famous question, "Where is everybody?" At first glance, the math seems undeniable. Even if only a tiny fraction of planets in the Milky Way could support life, there should still be countless civilizations out there, some of which might have had billions of years to expand across the galaxy. So why haven't we picked up a single radio signal, found any alien artifacts, or detected signs of sprawling cosmic engineering? The unsettling possibilities either reveal something profound about the universe or about us. One chilling explanation is the Great Filter, a barrier so catastrophic that nearly all civilizations hit a wall before they can spread beyond their home world. Maybe complex life is far rarer than we think, or perhaps every advanced society inevitably destroys itself through climate collapse, war, or runaway technology. If true, the question isn't just where aliens are. It's whether we're doomed to vanish before ever finding them, but not all theories are so grim. The zoo hypothesis suggests we're being intentionally left alone, observed from a distance like animals in a cosmic wildlife preserve. Alternatively, aliens might communicate in ways we can't yet detect, using neutrino beams or quantum entanglement instead of radio waves. There's even the eerie possibility that we are alone, the first or only intelligence in a universe just waking up to life. The longer the silence persists, the more profound the implications. Every new exoplanet discovery raises the stakes. If life is common, the absence of contact becomes harder to explain. Whether the answer lies in physics, sociology, or something beyond our current understanding, the Fermi Paradox forces us to confront not just the mysteries of space, but the fragility and rarity of our own existence. And maybe, just maybe, the silence isn't a dead end, but a clue waiting to be deciphered. Deep in the afterglow of the Big Bang, scientists found something that shouldn't be there, a cosmic spine running through the universe like a hidden seam. It's called the Axis of Evil, and no, that's not the title of a sci-fi thriller. This eerie alignment in the cosmic microwave background, the oldest light in existence, throws a wrench into one of astronomy's most cherished principles, that the universe on a grand scale should look the same in every direction. When researchers mapped the CMB's temperature fluctuations, they expected randomness, a celestial snowstorm frozen in time. Instead, they discovered peculiar patterns. Some fluctuations appeared oddly aligned along a specific axis, as if the universe had subtly picked a side. If confirmed, this could mean space isn't as uniform as we thought, or worse, that our entire cosmic neighborhood might be tilting towards something colossal beyond the observable horizon. Skeptics argue it could just be a cosmic coincidence, a trick of statistics in an otherwise isotropic cosmos. But the odds of this alignment happening by chance? Less than 1 in 1,000, that's like rolling a die 50 times and getting the same number every single time. Some theorists suggest wilder possibilities. Could this axis be an imprint of a pre-Big Bang structure, a relic from a prior universe, or evidence that dark energy isn't evenly distributed, tugging at spacetime in ways we can't yet explain? What makes this discovery so explosive is how it chips away at foundational assumptions. The cosmological principle, the idea that no place in the universe is special, underpins everything from galaxy formation to Einstein's equations. If the axis of evil holds up under deeper scrutiny, it wouldn't just rewrite textbooks, it could force us to rethink gravity itself. New telescopes like the Simons Observatory are already hunting for answers in the CMB's faint whispers. Until then, this cosmic riddle lingers, an invisible line drawn across the sky, daring us to question whether the universe is truly as random as we once believed. Among the countless space rocks hurtling through our solar system, one stood out like a cosmic hitchhiker passing through town, Oumuamua. In Hawaiian, its name means scout or messenger from afar, and when astronomers spotted it in 2017, it lived up to that title in the most bizarre way. This wasn't just another asteroid or comet, it was the first confirmed visitor from beyond our solar system, and it behaved like nothing we'd ever seen. At first glance, Oumuamua's trajectory was puzzling enough. Unlike local comets that loop around the Sun in predictable orbits, this object slingshotted inward at a steep angle, moving too fast to be bound by our star's gravity. But the real shock came when telescopes tracked its movement. Instead of slowing down as expected, it sped up slightly as it left something comets only do when outgassing vapor heats them like a rocket. Yet Oumuamua showed no visible tail, no gas cloud, no icy debris. It was as if an invisible hand gave it a gentle push. Then came the shape. Most asteroids resemble lumpy potatoes, but Oumuamua appeared oddly flattened, like a cosmic pancake tumbling end over end. Combined with its reddish hue similar to organic rich objects in the outer solar system, scientists scrambled for explanations. Some proposed it might be a rare hydrogen iceberg, a chunk of frozen hydrogen slowly evaporating in sunlight without leaving detectable traces. Others suggested it could be a fragment sheared off a Pluto-like world, ejected from some distant star system. But let's address the cosmic elephant in the room, the fleeting speculation that Oumuamua might be artificial. Harvard astronomer Avi Loeb famously raised the possibility that its acceleration and shape could align with a light sail, a thin, alien-built probe pushed by starlight. While most researchers dismiss this as improbable, the very fact it sparked such debate speaks volumes. Here was an object that defied easy classification, forcing us to confront how little we know about what might drift between stars. As Oumuamua faded from view, it left behind more questions than answers. Was it a weirdly shaped rock behaving in unexpected ways, or evidence that interstellar space is full of objects unlike anything in our own solar system? Future telescopes like the Vera Rubin Observatory might catch more of these visitors, giving us a better sample to study. Until then, Oumuamua remains a tantalizing hint that sometimes the universe sends envoys we're not quite equipped to understand. High above our planet, hidden in the swirling dance of human-made satellites and space junk, a legend has taken hold, one that refuses to fade. Meet the Black Knight satellite, a supposed alien artifact that conspiracy theorists claim has been silently orbiting Earth for thousands of years. The stories are dramatic, an ancient extraterrestrial probe monitoring humanity, its origins lost to time. But peel back the layers and you'll find a mystery built on intriguing misunderstandings and the timeless allure of the unexplained. The myth traces back to the late 1950s when unusual radio signals were reportedly detected by both amateur operators and early satellite trackers. Some believed they'd stumbled upon signals from an artificial object of unknown origin, something that shouldn't be there. Then came the infamous photograph, a dark, irregular shape captured during a 1998 space shuttle mission, which some claimed was the Black Knight itself. The image spread like wildfire, fueling speculation about its unnatural structure and impossible orbit. Yet reality paints a far simpler picture, that iconic photo. Likely just a thermal blanket lost during a spacewalk, the strange signals, experiments from early satellites like Explorer 1, or even natural radio emissions bouncing off the ionosphere. Even the supposed 13,000-year-old orbit defies physics. Human-made objects can't stay aloft that long without decaying. Astronomers and debunkers have dismantled the Black Knight's credibility piece by piece, yet its legend thrives. So why does this myth persist with such stubborn vitality? Part of it lies in our deep-seated fascination with the idea that we're not alone, that some unseen watcher lingers just beyond our reach. The Black Knight taps into the same primal wonder that makes us stare at the stars and whisper, what if it's a modern folktale, blending our awe of space with the thrill of conspiracy, proving that sometimes a good story outweighs cold, hard facts? But perhaps the most revealing truth here isn't about aliens, it's about us. The Black Knight endures because mysteries, even debunked ones, remind us that the universe still feels vast and untamed. In an age where science has mapped the human genome and photographed black holes, we still crave enigmas that defy easy answers. Whether space junk or cosmic legend, the Black Knight isn't just a satellite myth, it's a mirror reflecting our endless hunger for wonder. Some regions of space glitter like cities at night, packed shoulder to shoulder with galaxies, but then there's the Boötes Void, a cosmic ghost town so unnaturally empty it defies explanation. Stretching an astonishing 330 million light-years across, this colossal sphere of near-nothingness would take light twice as long to cross as the entire Milky Way is wide. Yet within its staggering volume, astronomers have catalogued only a handful of lonely galaxies, like a dozen marbles lost in an airplane hangar. The moment scientists realized this void wasn't just bad luck in their observations, the universe's rulebook seemed to tear. Standard cosmology predicts matter should clump together somewhat evenly, with filaments and clusters forming a cosmic web. But the Boötes Void is a hole punched straight through that web, a place where the universe forgot to scatter its stars. So how could such a vacuum exist? Some theorists propose mind-bending answers, like the void being a scar from an ancient collision with a parallel universe, a bubble of distorted space-time left behind. Others suggest it's evidence of supermassive black holes merging in the early cosmos, clearing their surroundings with unimaginable force. But the simplest explanation, that it's just a freak statistical fluke, doesn't sit right either. Simulations show voids this large should be vanishingly rare, appearing perhaps once in the observable universe. Yet here it is, staring back at us. Adding to the intrigue, the few galaxies trapped in the void's grip behave strangely. Many are oddly isolated, evolving without neighbors to shape them like cosmic castaways adapting to solitude. Their very existence challenges theories about how galaxies form and interact, hinting that extreme environments might rewrite the rules of stellar evolution. What makes the Boötes Void so haunting isn't just its emptiness, it's the questions it forces us to confront. Are we seeing a gap in our knowledge or a literal gap in reality? Could other voids like this lurk beyond our view? New sky surveys promise to map the cosmos in unprecedented detail, hunting for clues in the darkness. Until then, this great nothing stands as a humbling reminder. Even in a universe overflowing with light, sometimes the loudest mysteries come from the places where nothing speaks at all. Far from the predictable world we experience every day, the universe operates by rules that seem ripped from the pages of science fiction. Take a pair of particles born from the same quantum event, separate them by light years, and they'll still mirror each other's states instantaneously, as if space and time between them simply don't exist. This isn't hypothetical, it's quantum entanglement, a phenomenon so bizarre Einstein famously dismissed it as spooky action at a distance. Yet today, scientists on the International Space Station are proving just how real and how bewildering this cosmic connection truly is. Here's what's mind-bending. When entangled particles are measured, one's behavior immediately dictates the other's, no matter how far apart they are. Imagine flipping a coin in Tokyo and seeing it land heads up, only to watch an identical coin in New York snap to tails at the exact same moment without any signal passing between them. That's the essence of entanglement, a link that defies classical physics' speed of light rulebook. Recent experiments aboard the ISS have pushed this phenomenon to its limits. By beaming entangled photons from Earth to satellites and measuring their states across orbital distances, researchers confirmed the effect holds firm even in the vacuum of space. But here's where it gets even stranger. Entanglement doesn't transmit information in any usable way. The correlation between particles only becomes clear after comparing measurements, meaning you can't exploit it to send faster than light messages. At least not yet. Some physicists speculate that entanglement might hint at a deeper layer of reality, where space and time emerge from a more fundamental quantum framework. Others explore wilder ideas like holographic universes or wormhole-like connections hidden beneath the math. Then there's the tantalizing prospect of quantum communication networks, ultra-secure systems where data is shared not through cables but through these ghostly, instantaneous links. Yet for all its potential, entanglement remains a puzzle wrapped in paradox. Does it reveal some flaw in our understanding of space-time, or is it simply showing us how little we've grasped about the universe's true nature? Every experiment peels back another layer of the mystery, proving that sometimes the weirdest phenomena aren't just curiosities, they're clues waiting to rewrite physics itself. For decades, two spacecraft hurtling toward the edge of our solar system carried an invisible passenger, a mystery so subtle it nearly slipped past NASA unnoticed. The Pioneer 10 and 11 probes, launched in the early 1970s, were engineering marvels, the first human-made objects to venture beyond the asteroid belt. But as they sailed deeper into the void, something odd happened. They began slowing down just a fraction more than mission control had calculated. At first, the discrepancy seemed trivial, a difference so small it could fit in the shadow of a decimal point. But over years of tracking, that tiny anomaly ballooned into a full-blown cosmic riddle. By the time Pioneer 10 crossed Pluto's orbit, it was hundreds of kilometers off course, as if an unseen hand was gently tapping the brakes. Scientists scrambled for explanations. Could it be gravitational tugs from undiscovered planets, solar wind pressure? Even the drag of interstellar dust was considered, but nothing matched the data. For a while, a radical idea gained traction. Had we stumbled upon a flaw in Einstein's relativity? Some theorists suggested a modified gravity model might be at play, hinting at physics beyond our current understanding. Then, in 2012, a team of researchers proposed a far simpler answer. After poring over decades of telemetry and old blueprints, they realized something unexpected: heat. The probe's radioactive power sources were emitting tiny amounts of thermal radiation, not perfectly symmetrical. This slight imbalance, they argued, created just enough recoil to explain the deceleration. Case closed, or so it seemed, yet whispers of doubt linger. Critics point out that while thermal radiation accounts for most of the anomaly, it doesn't perfectly align with all the observed drift. Could there still be a sliver of unexplored physics hiding in the data? Or is this a testament to how even the most meticulous science can overlook mundane details, like the gentle push of warmth escaping a spacecraft's aging metal skin? The Pioneer anomaly stands as a humbling lesson in cosmic detective work. Sometimes the universe's greatest puzzles aren't solved by grand revelations, but by patient scrutiny of the ordinary. And sometimes, just sometimes, the answers we think we found leave room for one final question mark. Just beyond the orbit of Neptune, the outer solar system doesn't fade gently into the void, it ends with a cosmic guillotine. Astronomers call it the Kuiper Cliff, a boundary so sharp it's as if someone drew a line in the celestial sand. Out past 50 astronomical units, that's 50 times farther from the Sun than Earth, the bustling field of icy Kuiper belt objects suddenly drops off into nothingness. It's not that the telescopes can't see farther, it's that the objects aren't there. This isn't how solar systems are supposed to behave. Normally, debris fields like the Kuiper belt should thin out gradually, like the fading ring of a splash in a pond. Instead, we're staring at a cliff edge so stark it hints at something dramatic. A hidden force sculpted this frontier. Some researchers speculate a long-lost rogue planet, perhaps 5 times Earth's mass, may have plowed through this region in the solar system's infancy, hurling debris inward and leaving a sterile zone in its wake. Others wonder if a close encounter with a passing star billions of years ago ripped away the outer material, leaving only a fossilized border behind. But the most electrifying possibility, there might still be something massive lurking out there, an unseen world whose gravity sweeps the area clean. The hypothetical planet 9, if it exists, could explain not just the Kuiper Cliff, but also the peculiar orbits of some distant objects like Sedna. Yet after years of searching, no telescope has spotted it. That leaves us with 2 unsettling options. Either we're missing a planet-sized needle in a cosmic haystack, or our models of how planetary systems form are missing a fundamental piece. What makes this mystery so compelling is how it forces us to confront the limits of our knowledge. Every new deep space survey, like those from the Vera Rubin Observatory, could turn up clues, perhaps a smudge of infrared light betraying a hidden world, or a cluster of orbits pointing to where we should look next. Until then, the Kuiper Cliff stands as a silent sentinel, marking the edge of the known and the threshold of the unexplained, and beyond it, only darkness for now. For all the breathtaking images of galaxies and nebulae, there's an embarrassing truth about our cosmic inventory. We've lost track of half the universe's stuff. Not dark matter, not exotic energy, but the ordinary atoms that make up everything we can see and touch. Scientists call this the missing baryon problem, and it's not just some accounting error. Where do you misplace an entire universe's worth of matter? The numbers don't lie. When we tally all the visible stars, gas clouds, and planets, then factor in estimates from the Big Bang's leftover radiation, we're coming up 50% short on normal matter, the baryons that form the building blocks of planets, people, and everything in between. That's like weighing a shipment of bricks at the factory, then realizing only half arrived at the construction site. So where's the rest? The leading theory is as elegant as it is elusive. These missing atoms might be hiding in vast, diffuse webs of superheated gas strung between galaxies. Too thin to glow with visible light, yet too energetic for radio telescopes, these cosmic filaments could cloak the universe's lost material in a form we've only just begun to detect. Recent breakthroughs with advanced X-ray telescopes like ESA's XMM Newton have finally spotted tentative signs, faint whispers of oxygen atoms heated to millions of degrees, stretched into thread-like structures spanning millions of light years. But confirming this isn't just about solving a puzzle. If these filaments hold the missing baryons, their distribution could reveal how the universe funneled matter into galaxies in the first place, and why some regions bloomed with stars while others became barren voids. Some researchers suspect powerful shock waves from colliding galaxy clusters might be puffing these gases into near invisibility, like steam vanishing into cold air. Others wonder if black holes or dark energy play a role in scattering the material beyond our current detection limits. The hunt is far from over. Next-generation tools like NASA's upcoming Lynx X-ray Observatory aim to map these faint structures in unprecedented detail, while radio arrays scour deeper frequencies for hidden signatures. What's striking isn't just the possibility of finding the missing matter. It's realizing how much of the universe's ordinary fabric still lurks in the shadows, invisible not by some exotic property, but simply because we hadn't looked in the right way. From stars to smartphones, everything tangible comes from these misplaced baryons. Tracking them down isn't just bookkeeping, it's rewriting our understanding of how the cosmos assembles its visible architecture. And somewhere in those ghostly filaments, the universe might finally be revealing where it stashed its other half. Astronomers have a favorite tool for measuring the universe, the Hubble constant, a number that tells us how fast everything is flying apart. But here's the catch: depending on how you measure it, you get two different answers, and not just slightly off enough to throw our entire understanding of cosmic expansion into question. This growing headache, known as the Hubble Tension, isn't just a technical hiccup. It's a full-blown crisis threatening to crack the foundation of modern cosmology. One method relies on the cosmic microwave background, the faint glow from the infant universe. By studying its ripples with satellites like Planck, scientists calculate an expansion rate of about 67 kilometers per second per megaparsec. Basically, how much faster space stretches between galaxies the farther apart they are. But when astronomers use nearby supernova and pulsating stars as cosmic yardsticks, they get a noticeably faster result, 73. That gap might sound small, but in a field where precision is everything, it's like two clocks ticking at different speeds in the same room. At first, researchers wondered if someone had made a mistake, but after years of cross-checking with cutting-edge tools, from gravitational lenses to even gravitational waves, the discrepancy stubbornly holds. This isn't just a case of messy data. The universe appears to be expanding faster now than our best models predict, hinting that something fundamental is missing from the equation. So what's breaking the cosmic speedometer? Some theorists point to dark energy, that mysterious force accelerating the universe's expansion. Could it be growing stronger over time rather than staying constant as we've assumed? Others suggest exotic possibilities, hidden interactions between dark matter and dark energy, or even extra dimensions subtly warping space-time where our telescopes can't see. Then there's the most radical idea of all, that Einstein's equations, the bedrock of cosmology, might need tweaking on the largest scales. The stakes couldn't be higher. If the Hubble tension leads us to new physics, it would rank among the greatest scientific breakthroughs of the century, a paradigm shift as profound as relativity or quantum mechanics. But until we crack it, this puzzle remains a glaring reminder. Even our most trusted cosmic maps might still have uncharted territories, and somewhere in that mismatch of numbers lies a clue waiting to rewrite the story of the universe itself. Moon rocks brought back by Apollo astronauts hold more than just ancient dust. They carry traces of a cosmic contradiction. When scientists analyzed these samples, they found something startling. Certain rocks were magnetized, as if frozen in time under the influence of a powerful magnetic field. There's just one problem. The Moon's core is far too small and sluggish to generate the kind of dynamo that creates such fields today. So why do these silent stones tell a different story? For decades, the leading theory argued that the Moon might have briefly hosted a magnetic dynamo early in its life, fueled by the frantic energy of its formation. The idea was that as molten metal churned in its core during those first chaotic years, it could have acted like a temporary cosmic generator. But newer evidence throws a wrench into that explanation. Some of these magnetized rocks date back to a period long after the Moon's fiery birth, a time when its core should have cooled into stillness. This leaves researchers scrambling for alternatives. Could massive asteroid impacts have jolted the core back to life, stirring it like a spoon in molten metal? Simulations suggest a colossal collision might have briefly reignited convection, giving the Moon a fleeting magnetic pulse. Others propose that as the Moon's mantle shifted in its youth, gravitational tugs from Earth might have kept the core churning far longer than expected, like tectonic tides stretching and squeezing a ball of molten iron. But the plot thickens. Recent studies of lunar meteorites, rocks blasted off the Moon's surface and later found on Earth, show signs of magnetization that don't neatly fit any of these models. Some even hint at a weaker but far more persistent field, leaving open the possibility that we've misunderstood the Moon's core entirely. Maybe it wasn't just bigger in the past or stirred by outside forces. Maybe it operated on principles we haven't even considered. What makes this mystery so tantalizing isn't just rewriting lunar history. It challenges our understanding of how small rocky worlds generate magnetism. If something as seemingly inert as the Moon once hid a dynamic heart, what other surprises might we find on asteroids or distant exomoons? NASA's upcoming missions, like the Lunar Vertex rover, aim to scour the Moon's surface for more clues. Until then, those ancient rocks keep their secrets, whispering of a time when Earth's quiet companion was far more than just a dead and dusty world. Picture a galaxy where the usual cosmic rules don't apply, where the hidden scaffolding of the universe seems to vanish. Meet NGC 1052 DF2, a ghostly collection of stars drifting through space with an almost impossible secret. It appears to have no dark matter at all. This discovery didn't just raise eyebrows, it sent shockwaves through astrophysics, challenging one of our most fundamental beliefs about how galaxies form. Dark matter isn't just some minor ingredient in the cosmic recipe, it's the glue holding galaxies together. Without its gravitational pull, spiral arms should fling apart, and clusters of stars should dissolve into chaos. Yet here's DF2, a wispy, faint galaxy where stars move at a leisurely pace, as if oblivious to the invisible anchor they're supposed to need. When researchers first calculated its mass, the numbers told a stunning story. What you see is what you get. No extra hidden mass, no unseen force, just stars drifting freely in defiance of decades of astrophysical dogma. The immediate reaction, skepticism. Could DF2 simply be a trick of perspective? It's dark matter lurking where our telescopes couldn't detect. Or had we stumbled upon a cosmic rebel, a galaxy that somehow formed without the universe's most abundant yet mysterious substance? Follow-up observations only deepened the puzzle. Not only did DF2 lack dark matter, but its globular clusters, dense knots of ancient stars, were far larger and more scattered than expected, as if they'd formed in an entirely different environment. Now the debate rages. Some scientists argue DF2 might be a failed galaxy, born from gas expelled during a violent galactic collision, leaving it star-rich but dark matter poor. Others propose even wilder ideas. Could its missing mass have been stripped away by a close encounter with a neighboring galaxy? Then there's the radical fringe. What if dark matter isn't always mandatory? Could certain galaxies, under rare conditions, assemble without it, forcing us to rethink how structure emerges in the cosmos? What makes DF2 so electrifying isn't just the anomaly, it's the way it holds a mirror to our assumptions. Every new galaxy we discover seems to reinforce dark matter's role until one doesn't. Is this a cosmic fluke or a clue that our understanding of gravity and mass is incomplete? As telescopes like JWST peer deeper into DF2's secrets, one thing's certain. In a universe ruled by dark matter's invisible hand, this outlier reminds us that even the most entrenched theories must leave room for the unexpected. High above Saturn's North Pole, a shape lingers that has no business existing, a perfect six-sided hurricane large enough to swallow 4 Earths whole. This is the Saturn Hexagon, a storm so precise it looks like nature cracked open a cosmic geometry textbook. While hurricanes on Earth spiral into messy curves, this one has held its razor-sharp edges for at least 4 decades, maybe longer. And scientists still can't fully explain why. At first glance, the hexagon seems to break the rules. Fluids, whether air, water, or Saturn's thick atmosphere, tend to swirl into circular vortices, not polygons. Yet here's this titanic structure spinning at 78,000 miles per hour. Its 6 sides so stable you could almost set a clock by them. When researchers recreated scaled-down versions in labs, spinning tanks of liquid reliably formed similar shapes. But those experiments lasted minutes. Saturn's version has outlasted entire generations of scientists. So what keeps this atmospheric oddity ticking? One theory points to deep jet streams, rivers of gas flowing at different speeds that shear against each other, creating stable waves. Imagine dragging a paddle through honey. The ripples might briefly form angles before smoothing out. On Saturn, those ripples could be locked in place by the planet's rapid rotation and the turbulence beneath its cloud tops. Others suggest the hexagon might be a towering standing wave, a kind of permanent atmospheric imprint, like a fingerprint pressed into the sky. But here's where it gets even stranger. The hexagon isn't just a static shape, it changes. During Saturn's long seasons, which last over 7 Earth years, its hues shift from blue to gold, and the storm's interior churns with smaller vortices. Some researchers speculate these transformations hint at deeper, hidden layers of circulation, like gears turning beneath the visible clouds. Could there be energy welling up from Saturn's interior, feeding the storm's endurance? Or is the hexagon just the visible tip of a far more complex atmospheric machine? The Cassini spacecraft gave us breathtaking close-ups, yet every answer seems to breed new questions. Even the hexagon sound translated into radio waves holds eerie musical patterns, as if the storm is humming some alien tune. While lab experiments prove such shapes can form, none explain why Saturn's version refuses to fade. Perhaps the most humbling lesson here isn't about storms or geometry, it's about how little we truly grasp the dynamics of other worlds. Earth's weather seems chaotic, but Saturn's hexagon whispers that there might be hidden order in the chaos, waiting to be decoded. And until we solve it, this six-sided enigma will keep orbiting at the edge of our understanding, a cosmic reminder that even the familiar laws of physics can twist into something extraordinary. The rusty plains of Mars seem barren at first glance, a frozen desert where nothing stirs. Yet beneath that lifeless surface, something is breathing. Not literally, of course, but the chemistry is undeniable. Plumes of methane gas periodically rise from the Martian soil, vanishing as suddenly as they appear. If Earth is any guide, this shouldn't happen without a source, either living organisms or active geology. And that's why NASA's Curiosity rover has been sniffing the Martian air like a detective hunting for clues in a cosmic whodunit. What makes these methane spikes so perplexing isn't just their presence, it's their inconsistency. Unlike Earth, where methane lingers for years thanks to atmospheric chemistry, Mars' thin air should break the gas down within centuries. So when Curiosity detected methane levels jumping by tenfold in just months, and then plummeting back to near zero, scientists were left scratching their helmets. It's as if someone is turning a faucet on and off beneath the planet's surface, releasing bursts of gas before shutting the valve tight. Two leading theories dominate the debate. The first points to microbes, specifically methanogens, simple organisms that thrive without oxygen and exhale methane as waste. On Earth, these creatures lurk in swamps, volcanoes, even the guts of cows. Could their Martian cousins be hiding in briny underground aquifers, metabolizing hydrogen and carbon dioxide to survive? The possibility is tantalizing, but there's a catch. No one's found direct proof of life, past or present, on Mars. That brings us to the second explanation: geology. Certain minerals, like olivine, can produce methane when they react with water in a process called serpentinization. Mars' volcanic past means these ingredients could still be simmering beneath the surface, reacting in slow motion as the planet cools. Then there's the wild card: clathrates, icy cages of methane trapped in frozen soil that might sporadically release their contents when warmed by seasonal shifts or meteor impact. Yet even these scenarios struggle to explain the methane's erratic behavior. If geology were the sole source, why the sudden spikes instead of a steady trickle? And if microbes are to blame, why haven't other biosignatures like complex organic molecules shown up alongside the gas? The European Space Agency's Trace Gas Orbiter, designed specifically to map Martian methane, has only deepened the mystery. While Curiosity catches whiffs of the gas from the ground, the orbiter often sees nothing from above, as if the methane vanishes before reaching high altitudes. Some speculate it's being destroyed by surface chemistry or absorbed by porous rocks before it can spread. What's clear is that every new detection, or lack thereof, adds another twist to the puzzle. Future missions like NASA Mars Life Explorer aim to drill deeper, literally and figuratively, into these enigmas. Whether the answer lies in subterranean life or exotic geology, one thing's certain: Mars is far from dead. It's a world with secrets still exhaling into the thin, cold air, daring us to decode their meaning. And until we do, those fleeting methane spikes will remain one of the most tantalizing maybes in planetary science. The universe isn't just expanding, it's running somewhere. Not haphazardly, not chaotically, but with eerie, coordinated momentum toward a point no telescope can see. Astronomers call it the dark flow, and it's as unsettling as it sounds. Imagine throwing confetti into the air only to watch every piece drift in the same direction against the wind. That's what scientists observed when they mapped the motion of thousands of galaxy clusters, all being pulled toward some invisible cosmic magnet lying beyond the edge of everything we know. At first, the discovery seemed impossible. After all, the Big Bang should have scattered matter evenly, leaving no direction more special than any other. But when researchers analyzed the slight temperature shifts in the cosmic microwave background, the ancient afterglow of the universe's birth, they found something bizarre. Galaxy clusters were moving together at blistering speeds of nearly 2 million miles per hour toward a single patch of nothingness. It wasn't gravity from anything in our observable universe causing this. So what was one spine-tingling possibility? The pull might be coming from outside our cosmic bubble. If the multiverse theory holds and other universes exist beyond our own, their gravitational influence could be leaking into ours, tugging galaxies like tides from an unseen ocean. Alternatively, the flow might trace back to a primordial flaw in spacetime itself, a kink left over from the Big Bang that's still dictating the motion of matter billions of years later. Skeptics aren't convinced. Some argue the dark flow could be a statistical mirage, an illusion born from incomplete data or hidden biases in how we measure cosmic motion. Others suggest it might stem from colossal, undiscovered structures lurking just beyond our observational limits, warping spacetime in ways we don't yet grasp. But here's the twist: the dark flow isn't just a curiosity. If real, it challenges one of cosmology's sacred principles that the universe on large scales should look roughly the same in every direction. Finding proof of an external force would mean our cosmos isn't an isolated island, but part of something far bigger and stranger. New telescopes like the upcoming Euclid mission could settle the debate by mapping galaxy motions with unprecedented precision. Until then, the dark flow remains a ghostly current in the cosmic sea, pulling us toward answers we might not even have the tools to comprehend yet. Whether it's a window into the multiverse or a quirk of physics, one thing is certain: the universe still has ways to remind us how little we truly see. Tucked away just 1,500 light-years from Earth, a cosmic oddity lurks in the constellation Monoceros, so tiny, so bizarre that astronomers almost missed it entirely. Meet the unicorn, a black hole so small it defies everything we thought we knew about how these gravitational monsters form. Weighing in at a mere 3 times the mass of our Sun, this pint-sized singularity exists on the razor's edge of possibility, challenging the laws of physics to explain how it could even exist. For decades, scientists believed black holes only formed from stars at least 20 times heavier than the Sun, massive enough to collapse into an infinitely dense point when their fuel ran out. Yet here's the unicorn, barely heavier than a neutron star, flouting the rules. Its surprising discovery came not from detecting the black hole itself, since these objects famously devour light, but by watching the strange dance of a nearby red giant star. This star wobbled as if tugged by an unseen companion, and when astronomers crunched the numbers, the only explanation was a black hole far smaller than any model predicted. So how does a black hole this tiny defy the odds? One theory suggests it might be the fossil of a failed supernova, a star that collapsed without the usual fireworks, quietly imploding into darkness. Others wonder if the unicorn was once part of a binary system. Its growth stunted after a stellar sibling siphoned away most of its mass. Then there's the wild card. Could some black holes form through entirely different processes, like the collision of ultra-dense neutron stars? But the unicorn's secrets don't stop there. Its existence hints at a hidden population of similar black holes, too small and quiet to detect by traditional means, lurking in our cosmic backyard. If that's true, stellar evolution might be far messier than our textbooks suggest, with black holes forming in ways we've never imagined. What makes this discovery truly electrifying isn't just the black hole's size, it's how close it is. Most known black holes are thousands of light years away, but the unicorn sits practically next door, offering astronomers an unprecedented chance to study an enigma up close. Future telescopes like the Vera Rubin Observatory could soon uncover more of these elusive mini-monsters, reshaping our understanding of how stars live, die, and sometimes vanish without a trace. Whether an astronomical fluke or the first of many, the unicorn stands as proof that even the darkest corners of space still hold surprises waiting just beyond the edge of our vision. 22nd phenomenon. The zombie star. Most supernovas go out with a bang, a single cataclysmic explosion that obliterates a star in one spectacular finale. But in 2014, astronomers stumbled upon a cosmic anomaly that refused to follow the script. IPTF-14 HLS, a star that didn't just explode, it came back to life and exploded again and again, like a celestial phoenix stuck in an endless loop. Dubbed the zombie star, this bizarre object brightened and dimmed at least 5 times over 2 years, as though it couldn't decide whether to live or die. Normally, a supernova's light fades after a few months as the shockwave dissipates, but IPTF-14 HLS kept reigniting, pumping out enough energy to outshine entire galaxies twice. Even stranger, the star seemed to be expelling material at wildly inconsistent speeds, some debris racing outward while other parts lingered, defying the clean, symmetrical explosions we're used to. Theories flew fast and furious. Some suggested a pulsational pair instability supernova, a rare event where a massive star's core becomes so hot it briefly creates matter and antimatter pairs, triggering repeated implosions and eruptions. The problem, even that wouldn't fully explain the zombie star's erratic behavior. Its energy output was off the charts, and the timeline stretched far beyond what models predicted. Others proposed even wilder ideas. Could this have been a magnetar, a highly magnetic neutron star forming inside the chaos, injecting fresh energy into the explosion like a cosmic defibrillator? Or was there some exotic, undiscovered physics at play? A stellar death throws unlike anything we've catalogued before. What makes IPTF-14 HLS so unsettling isn't just its defiance of expectations, it's the lingering question of how many more stars like it might be hiding in plain sight. Had astronomers not been watching at just the right moment, they might have dismissed it as a fluke. Now, telescopes scour the skies for similar anomalies, hunting for clues in the ashes of other supernovas. If one thing's certain, it's that the universe still holds stellar spectacles we can't yet explain. And somewhere out there, another undead star might be waiting ready to rewrite the rules of death and rebirth all over again. Some of the first images from the James Webb Space Telescope should have been a triumph, a glimpse into the universe's infancy, revealing the earliest flickers of starlight. Instead, they sent shockwaves through the astronomy community. The data showed massive, fully formed galaxies dating back to just 300 million years after the Big Bang, far earlier than our models say such cosmic giants should exist. It's like finding a skyscraper in the ruins of an ancient civilization that hadn't yet invented the wheel. These galaxies, with catchy names like Glass Z13 and Sears 93316, shouldn't have had time to assemble. According to standard cosmology, the early universe was a fog of hot gas, slowly cooling and clumping into the first small stars. Massive galaxies require billions of years to grow through mergers and collisions, yet here they are, appearing almost instantly on cosmic timescales. Now scientists are scrambling for explanations. Some suggest dark matter might have clumped together faster than we thought, acting as a gravitational scaffold for these early giants. Others wonder if the first stars formed differently, perhaps born in hyper-efficient bursts that bypassed the usual slow growth, but the most radical idea, that our timeline for the Big Bang itself might need tweaking. Could the universe be older than we think, or did structure emerge under unknown physical laws? Skeptics argue these galaxies might not be as massive as they appear. Dust or observational quirks could be distorting the measurements. Yet with each new JWST discovery, the anomaly only deepens. These cosmic toddlers shouldn't exist, and yet they stare back at us from the edge of time, defying every expectation. What's thrilling isn't just the potential rewrite of cosmic history, it's the reminder that every time we build a better telescope, the universe hands us a new mystery. Whether it's unseen physics, flaws in our models, or something even stranger, one thing's clear: our story of how galaxies form is far from complete. And somewhere in that ancient light, the answers are waiting, if we can just learn to read them. 24th phenomenon, the cosmic web's missing link. If you could shrink down to the size of a quark and gaze at the universe from afar, you wouldn't see isolated galaxies floating in darkness. You'd witness an intricate, shimmering web. Stretching across billions of light years, this vast network of gaseous threads connects every galaxy, cluster, and supercluster like cosmic highways. Astronomers call it the cosmic web, and it's the hidden skeleton of the universe. But there's a catch: we've only seen glimpses of its full structure, because most of its threads are so faint, they've been nearly impossible to detect until now. These filaments, composed of diffuse hydrogen gas, are more than just ethereal bridges. They're the universe's delivery system. Over billions of years, gravity funnels matter along these pathways, feeding galaxies the raw materials to build stars, planets, and ultimately us. Without this web, galaxies would starve in isolation, scattered like islands with no supply lines. Yet despite their importance, these filaments remain maddeningly elusive. They're too thin to emit much light, too cool to glow in X-rays, and too sparse to cast shadows. So how do you map something that's practically invisible? The breakthrough came with a clever trick, using the universe's brightest flashlights, quasars, to backlight the web. When light from these hyperactive galaxies passes through a filament, it leaves a fingerprint-specific wavelength absorbed by the hydrogen gas. It's like shining a spotlight through fog, revealing the swirling mist in its beam. Recent observations with instruments like the Keck Cosmic Web Imager have finally captured these faint traces, confirming that filaments stretch farther and weave more densely than simulations predicted. But the mystery deepens. Some filaments appear far hotter than models suggest, as if energized by unseen forces. Could turbulence from colliding galaxy clusters be heating the gas? Or is there some exotic physics at play, like dark matter particles interacting in ways we don't yet understand? Even stranger, a few filaments seem to glow faintly on their own, possibly lit up by shocks or radiation from nearby star-forming regions. These aren't just academic curiosities. Understanding the cosmic web could solve one of astronomy's biggest puzzles, the missing baryon problem. For decades, half the universe's ordinary matter has been unaccounted for, and many suspect it's hiding in these nearly invisible strands. If so, the web isn't just scaffolding. It's the universe's lost and found department, holding onto atoms that should have been part of galaxies but slipped through the cracks. New telescopes like the upcoming Athena X-ray Observatory aim to probe these filaments in unprecedented detail, hunting for faint emissions and hidden structures. And as we piece together this cosmic blueprint, we're learning something profound. The universe doesn't just build galaxies, it connects them in a silent, sprawling network that's been hiding in plain sight all along. From this grand perspective, every star, every planet, and even we ourselves are products of this delicate web, threaded into existence by tendrils of gas we're only now beginning to see. And somewhere in those faint, glowing strands, the universe might be whispering its next secret. Buried deep beneath the frozen wastes of Antarctica, scientists are hunting for phantoms, not ghosts of the supernatural kind, but elusive particles that slip through our planet like it isn't even there. Neutrinos, often called the universe's stealthiest messengers, rarely interact with matter. Trillions pass through your body every second, leaving no trace. Yet when researchers finally catch these cosmic specters on sensitive detectors, they behave in ways that defy expectations, flickering between identities in a bizarre dance no current theory fully explains. The puzzle begins with a phenomenon called Neutrino Oscillation. These particles come in three known types: electron, muon, and tau, and can shapeshift between them as they travel. That alone was a groundbreaking discovery, proving neutrinos have mass. But recent experiments reveal something even stranger. The oscillations don't match predictions. Some neutrinos seem to vanish entirely, hinting at a fourth, even more elusive variety, sterile neutrinos, which would interact only through gravity, not the standard forces. Detecting them is like searching for invisible ink under a blacklight. When scientists at facilities like Fermilab or the Ice Cube Neutrino Observatory, a sensor array buried in Antarctic ice, track neutrinos from reactors or cosmic rays, their data shows gaps, fewer particles arriving than should. It's as if a portion of them stepped into a hidden dimension mid-journey. The implications are staggering. Sterile neutrinos could be a bridge to dark matter or evidence of extra dimensions folded into spacetime. Alternatively, the anomaly might signal flaws in our models of quantum physics, suggesting neutrinos obey rules we haven't yet imagined. Not everyone's convinced. Critics argue experimental errors or unaccounted for background noise could explain the discrepancies. But as detectors grow more precise, from IceCube's upgrade to India's upcoming I know, the anomalies persist. Whether the answer lies in undiscovered particles or rewritten physics, one thing's clear: the universe's quietest particles might be shouting clues about its deepest secrets. And beneath the ice, in the silence of the detectors, science inches closer to hearing them. 26th phenomenon. The Red Rectangle Nebula. Most nebulae sprawl across space like celestial watercolor paintings, swirling, asymmetric clouds of gas and dust painted by the chaos of stellar winds and explosions. Then there's the Red Rectangle Nebula, a cosmic structure so precise, so unnervingly geometric, it looks as though the universe cracked open a protractor. Floating about 2,000 light-years away in the constellation Monoceros, this baffling formation glows with an eerie crimson hue, its nested rectangles stacked like a corridor to another dimension. What makes this nebula so extraordinary isn't just its vivid color. It's the sharp, almost artificial symmetry of its structure. Unlike the ragged tendrils of the Crab Nebula or the billowing curves of the Orion Nebula, the red rectangle's sides are crisp, its angles unnaturally uniform. At its heart, two aging stars pirouette around each other, locked in a gravitational dance that might hold the key to this cosmic origami. Astronomers suspect the nebula's bizarre shape comes from these twin stars sloughing off layers of gas and dust in perfectly opposed cones. As material escapes their pull, it's funneled into a dense disk around the binary system, sculpted by stellar winds into those striking rectangular layers. Think of it like a spinning sprinkler spraying water in precise arcs, except here the water is superheated plasma and the sprinkler is a dying star system. Yet even this elegant explanation leaves gaps. Why don't turbulence or magnetic fields disrupt the symmetry? And why does the red rectangle emit such an unusual mix of light, including mysterious infrared bands dubbed the unidentified infrared features, which no known molecule fully explains? Some researchers speculate complex carbon-based compounds, perhaps even precursors to life, might be forming in those crimson corridors, Then there's the deeper question: is this nebula a rare cosmic fluke, or proof that order can emerge naturally from chaos under the right conditions? Most nebulae are born from violent supernova collisions or the violent outflows of young stars. The red rectangle, by contrast, feels like a carefully crafted monument, a reminder that the universe sometimes trades its paintbrush for a ruler. As telescopes like JWST turn their gaze toward this crimson enigma, they might uncover whether its geometry is a fleeting phase or a hidden blueprint for how certain stars choose to bow out. One thing's certain: in a cosmos so often defined by turbulence, this eerie rectangle stands as a quiet rebellion, a whisper that even in the vast, chaotic dark, there's room for perfect angles. Imagine a world where the ground beneath your feet isn't rock, sand, or ice, it's diamond. Gleaming, massive, and possibly worth quadrillions by earthly standards, 55 Cancri E isn't just another exoplanet. This scorching inferno, orbiting perilously close to its star, might be the universe's most extravagant jewel, a carbon-rich sphere where conditions could have crushed its very crust into crystalline perfection. Discovered in 2004, this rogue gem defies expectations. Most planets form from the same cosmic soup as their stars, rich in oxygen and silicon. But 55 Cancri E's parent star has twice the carbon content of our Sun, suggesting the planet itself could be saturated with the element. Under extreme heat and pressure, carbon crystallizes into diamond, and with surface temperatures soaring above 2000 degrees Celsius, this world might be studded with literal mountains of the stuff. Yet the real puzzle isn't just its sparkle, it's how such a planet could exist at all. One theory suggests 55 Cancri E might be the corpse of a gas giant, its outer layers stripped away by its star, leaving behind a carbon-heavy core. Alternatively, it could have formed in a disk teeming with carbon compounds, like soot hardening into something far more precious. But there's a catch. Follow-up studies show its atmosphere might contain hydrogen and helium, hints that this diamond planet could also hide stranger chemistry beneath its glittering facade. The implications stretch beyond cosmic bling. If worlds like this are common, they challenge our assumptions about planetary diversity, proving the universe crafts planets from recipes we've never tasted. Imagine solar systems where ruby-rich worlds or graphite plains exist, each sculpted by their star's unique elemental palette. New telescopes like JWST are peering into 55 Cancri E's atmosphere, hunting for clues in the light filtering through its haze. Whether it's truly a diamond world or something even more exotic, one thing's certain: this planet shatters the mold, proving that when it comes to cosmic wonders, sometimes truth is far richer than fiction. 28th phenomenon, the empty supernova in the grand theater of the cosmos. Few spectacles match the drama of a supernova, a star's final, explosive goodbye, outshining entire galaxies for weeks in a blaze of glory. But sometimes the stage is set, the lights dim, and nothing happens. Across the universe, astronomers are catching massive stars in the act of vanishing, not with a bang but with a whisper. No fireworks, no lingering nebula, just an eerie absence where a luminous giant once burned. These are the empty supernovas, and their silence speaks volumes. Take N6946 BH1, a star 25 times the mass of our Sun, nestled in a galaxy 22 million light-years away. For years, telescopes watched it brighten, as if gearing up for a spectacular explosion. Then, in 2015, poof, it simply winked out of existence. Infrared observations later revealed a faint glow where the star had been, but no telltale shockwave, no expanding debris. The leading theory: this star might have skipped the supernova stage entirely, collapsing directly into a black hole without the usual cosmic fanfare. But here's the catch: stellar physics says massive stars shouldn't be able to do that. When a star's core runs out of fuel, it implodes under its own gravity, triggering a shockwave that blasts the outer layers into space, the supernova we're familiar with. For a star to vanish quietly, something must short-circuit that process, as if the core swallowed its own death cry. One possibility is failed supernovas, where the collapse is so efficient that the star's outer layers fall inward too fast to rebound. Another wildcard, hypermassive stars might collapse straight into black holes under extreme conditions, their gravity too strong for even light to escape the implosion. There's even speculation that some of these vanishing acts could involve exotic physics like dark matter interactions sucking energy from the core before it can detonate. Yet every explanation raises new questions. If stars can collapse without explosions, where does all that pent-up energy go? Could this explain why we've detected fewer supernovas than predicted in certain galaxies? And most intriguingly, are these quiet disappearances actually more common than we've realized, hiding in plain sight until now? Upcoming observatories like the Rubin Legacy Survey could settle the debate, scanning millions of stars for sudden disappearances. Until then, these ghostly exits remind us that even in death, stars defy expectations. Some leave a glittering legacy, others just an empty stage and a mystery waiting in the dark. 29th phenomenon. Hoag's object, the galaxy that shouldn't exist. Picture a flawless cosmic bull's-eye spinning silently in the void, a ring of brilliant blue stars encircling a golden core with near-perfect symmetry. This isn't an artist's rendering or a Hubble image enhanced for drama. It's Hoag's object, a galaxy so bizarrely pristine it makes even seasoned astronomers pause. Unlike the messy spirals or chaotic ellipticals we're used to, this celestial oddity defies the playbook, offering no clear clues as to how something so perfectly balanced could form naturally. Discovered by astronomer Arthur Hoag in 1950, this ring galaxy sits 600 million light-years away, a floating enigma drifting in the constellation Serpens. At first glance, it looks like two separate galaxies, a young, star-forming ring hugging an ancient yellowish core separated by a dark, starless gap. But here's the twist, they're one and the same. The ring's vibrant blue clusters blaze with newborn stars, while the core glows with aging suns, creating a celestial yin-yang that shouldn't coexist in such harmony. So how does a galaxy like this come to be? The usual suspects, collisions, mergers, or gravitational disruptions don't quite fit. Most ring galaxies, like the famous cartwheel, form when a smaller galaxy punches through a larger one, rippling stars outward like a stone dropped in water. But Hoag's object shows no signs of a violent past. No debris, no twisted trails of stars, just eerie, undisturbed symmetry. That leaves scientists with two equally intriguing possibilities. 1. This galaxy is the product of an ancient collision so perfectly aligned that all traces of chaos have smoothed away over billions of years. Or 2. It's a cosmic unicorn, a rare configuration where instabilities in a primordial gas cloud somehow birthed this balanced structure without any outside help. Both explanations stretch our understanding of galactic evolution to the limit. Even stranger, the void between the ring and core isn't entirely empty. Ultra-sensitive observations reveal faint, dusty filaments threading the gap, hints of something bridging the divide, though whether it's leftover material from formation or the ghost of a long-lost collision remains a mystery. What makes Hoag's object so mesmerizing isn't just its beauty, it's the questions it forces us to confront. Are we seeing a galactic masterpiece sculpted by chance, or evidence of processes we've yet to uncover? Upcoming telescopes like the James Webb Space Telescope might finally spot similar structures hiding in the distant universe, revealing whether this is a cosmic fluke or a hidden chapter in how galaxies evolve. For now, this celestial oddity drifts in perfect stillness, a silent challenge to every model we've built. In a universe so often defined by chaos, Hoag's object whispers that sometimes, against all odds, perfection finds a way. 30th phenomenon, the Hercules-Corona Borealis Great Wall. Think you've grasped the sheer scale of the cosmos? Think again. Hanging in the depths of space like a celestial mountain range, the Hercules-Corona Borealis Great Wall redefines what we thought possible. A monstrous filament of galaxies stretching a mind-numbing 10 billion light-years across. That's 1/10 the diameter of the entire observable universe. And here's the real kicker. This gargantuan structure shouldn't exist, at least not according to our best models of cosmic evolution. Discovered in 2013 while mapping gamma-ray bursts, the universe's brightest explosions, this titanic formation isn't just big, it's impossibly big. The cosmic principle, a cornerstone of modern cosmology, states that matter should be distributed more or less evenly on the largest scales. Yet the Great Wall laughs in the face of that idea, clustering galaxies in a dense, ribbon-like structure so vast it makes superclusters look like specks of dust. So how does something this colossal emerge so early in cosmic history? One theory suggests it's a fossil relic of the universe's infancy, a scar left behind by ancient fluctuations in the primordial soup of the Big Bang. Picture ripples frozen in time, magnified by expansion into a sprawling cosmic backbone. Others speculate that dark matter's invisible web might have funneled galaxies into these absurdly long chains, like beads threaded on an unseen string. But skeptics aren't ready to rewrite the textbooks yet. Some argue the Great Wall might be an illusion, a trick of perspective where unrelated galaxies appear connected from our viewpoint. Yet the statistical improbability of such a coincidence is staggering. If this structure is real, it forces us to confront a humbling truth. We might not understand the universe's architecture as well as we thought. New telescopes like ESA's Euclid are scanning deeper into the cosmic web, hunting for clues in the distribution of galaxies and dark matter. What they find could either cement the Great Wall's status as a cosmic anomaly or reveal it's just the first of many, hinting at a universe far more structured and far stranger than we'd ever imagined. One thing's certain, in a cosmos where we've grown accustomed to incomprehensible vastness, this wall stands as a monument to the unknown, a silent, sprawling question mark written across the sky. And its very existence dares us to ask, what else have we missed? 31st phenomenon. The dark energy surveys cosmic anomaly for over 2 decades. Scientists have clung to one reassuring certainty about dark energy, the mysterious force accelerating the universe's expansion. It's smooth. Like an invisible mist evenly filling the cosmos, it was thought to exert its push uniformly across all of space. But now, a groundbreaking survey is tearing that assumption apart. The Dark Energy Survey, one of the most ambitious mapping projects in history, has uncovered something unsettling. The universe's large-scale structure isn't as even as it should be. Instead, galaxies and galaxy clusters appear clumped together in patches that defy our models, as if dark energy itself is gathering in hidden currents. Peering into the depths of the cosmos, the survey analyzed the shapes and positions of over 300 million galaxies, using their subtle distortions to trace the unseen scaffolding of dark matter and, by extension, the influence of dark energy. What they found was a cosmic quilt with unexpectedly thick stitches. Some regions of space seem emptier than predicted, while others are crowded beyond probability, like bubbles in a pot of water boiling unevenly. If dark energy were truly uniform, these irregularities shouldn't exist. So what's behind the cosmic lumpiness? One possibility is that dark energy isn't the constant force we've assumed. Maybe it fluctuates, growing stronger in some areas and weaker in others, like an irregular tide pulling at spacetime itself. Alternatively, these imbalances could be ancient echoes from the universe's birth, primordial ripples frozen into the fabric of reality, only now revealing themselves as the cosmos stretches thin. Then there's the radical third option, that we've misunderstood dark energy entirely. Perhaps it's not a single force but a spectrum of phenomena, or even an illusion created by gaps in our grasp of gravity. Critics caution that statistical noise or observational biases could still explain the anomalies, but the sheer scale of the survey makes that unlikely. As new telescopes like the Vera Rubin Observatory join the hunt, the stakes couldn't be higher. If dark energy isn't uniform, everything from the fate of the universe to the very laws of physics might need rethinking. For now, this cosmic unevenness remains a tantalizing clue, a whisper that the universe's greatest mystery might be even stranger than we imagined. One thing's certain, the deeper we look, the more the cosmos refuses to conform to our expectations. And somewhere in those galactic clumps and voids, the next revolution in cosmology could be waiting. 32nd phenomenon, the Venusian Phosphine mystery high in the toxic skies of Venus, where temperatures roast metal and sulfuric acid rains from thick yellow clouds. Scientists stumbled upon a whisper of something that shouldn't be there. In 2020, telescopes picked up traces of phosphine, a gas long considered a potential signature of life, floating miles above the planet's hellish surface. The discovery ignited a firestorm of debate. Was this a clue to alien microbes thriving in the clouds, or evidence of exotic chemistry rewriting the rules of a world we thought we understood? On Earth, phosphine is primarily associated with biological activity. It's produced by bacteria in oxygen-starved environments like swamps and, yes, even animal intestines. Finding it on Venus, a planet so hostile it melts landers within hours, was like spotting a candle flickering in a blast furnace. The gas's presence defies conventional explanations because Venus's atmosphere should destroy phosphine almost instantly. Yet there it was, lingering in detectable amounts, as if something was continuously replenishing it. The scientific community fractured instantly. One camp argued for extreme caution, pointing out that unknown geological or chemical processes could mimic phosphine's signature. After all, Venus is a world of supercritical carbon dioxide, volcanic plumes, and reactions we've barely begun to model. Maybe lightning or high-pressure mineral interactions could produce the gas without life's involvement, though no known process neatly fits. The other camp dared to consider the unthinkable. Could hardy microorganisms survive in Venus's upper clouds? Unlike the planet's crushing surface, its cloud layers hover at a relatively mild 60 degrees Celsius with pressure similar to Earth's mountaintops. Some extremophiles on Earth thrive in acidic environments, leading to speculation that Venusian microbes, if they exist, might float in droplets shielded by sulfur compounds while metabolizing trace gases into phosphine. But skepticism runs deep. Follow-up observations have been inconclusive, with some teams detecting phosphine and others finding nothing. Even if the gas is real, proving a biological source would require ruling out every other possibility, a monumental task for a planet we've barely scratched. Upcoming missions like NASA Da Vinci Plus and ESA's Envision might finally settle the debate, probing Venus's atmosphere with precision instruments. Until then, this enigmatic gas keeps its secrets floating in the acid haze, a tantalizing maybe in the search for life beyond Earth. Whether the answer points to undiscovered chemistry or the first hints of extraterrestrial biology, one thing's certain: Venus, long dismissed as a dead world, just became one of the solar system's most intriguing puzzles. And somewhere in those swirling clouds, the truth may be waiting just out of reach. 33rd phenomenon, the blob in the Orion Nebula, nestled in the sword of the Orion constellation, where newborn stars ignite like cosmic fireworks. Something lurks in the shadows, an enigma wrapped in swirling gas and bathed in eerie light. Astronomers call it the blob, a free-floating mass of glowing matter too bizarre to categorize. It's not quite a star, not quite a planet, and definitely not a nebula. Instead, it drifts defiantly in the Orion Nebula's stellar nursery, challenging every label we try to pin on it. At first glance, the blob resembles a failed star, a brown dwarf perhaps, too massive to be a planet but too small to sustain nuclear fusion. Yet closer inspection reveals contradictions. Its temperature and luminosity don't match any known brown dwarf model. Some observations suggest it might even be a rogue planet, ejected from its home system and left to wander the nebula's turbulent seas. But here's the twist: rogue planets don't typically glow like this. The blob emits its own faint, fluctuating light, as if fueled by some hidden energy source we can't yet explain. Then there's the peculiar way it interacts with its surroundings. Unlike isolated planets or dead stars, the blob seems intricately linked to the Orion Nebula's gas clouds, sculpting them like an invisible hand pushing through mist. Some researchers theorize it could be a protostar in stasis, a celestial object that stalled mid-formation, trapped in cosmic limbo. Others wonder if it's something far stranger, a primordial fragment of the nebula itself, a knot of superheated gas and dust that never quite condensed into a star. But the most tantalizing possibility, the blob might represent an entirely new class of celestial object, one that doesn't fit neatly into our current catalogs. If true, it could rewrite our understanding of how cosmic bodies form and evolve, forcing us to reconsider the boundaries between stars, planets, and nebulous oddities. New telescopes like JWST are turning their gaze toward this cosmic misfit, peeling back layers of its mystery with infrared eyes. Whether it's a failed star, a rogue planet with a secret, or something entirely unprecedented, the blob stands as a humbling reminder. Even in the most studied corners of the sky, the universe still has surprises up its sleeve. And sometimes the most compelling discoveries aren't the ones that fit our models, but the ones that shatter them. 34th phenomenon, the Andromeda Paradox, right next door to the Milky Way. Cosmically speaking, our galactic neighbor Andromeda should feel familiar. After all, it's a spiral galaxy like ours, a whirl of stars and dust spinning through the void. But here's the cosmic curveball: Andromeda's rotation defies expectations. The outer stars orbit too fast, as if gripped by an unseen force, yet even accounting for dark matter, the numbers don't add up. This mismatch isn't just a small discrepancy, it's a full-blown rebellion against our understanding of how galaxies move. For decades, astronomers assumed Andromeda's rotation would mirror predictions based on visible mass and dark matter models. Instead, observations reveal its outer edges whip around at speeds that make no sense unless something extraordinary is at play. One possibility: Andromeda's dark matter halo isn't shaped the way we thought. Most simulations assume dark matter forms a smooth, spherical cloud around galaxies. But what if Andromeda's halo is lopsided or clumped in ways we've never detected? Then there's the more unsettling alternative. Could our models of gravity itself be missing a piece when applied to such massive scales? Modified Newtonian dynamics (MUND), a controversial theory suggesting gravity behaves differently in weak galactic fields, does predict rotation curves like Andromeda's without invoking extra dark matter. But MUND struggles to explain other cosmic phenomena, leaving most scientists hesitant to abandon the dark matter framework entirely. Complicating matters further, Andromeda isn't alone. A handful of other galaxies show similarly perplexing spins, hinting this might be more than a one-off fluke. Is there a hidden variable, an unseen interaction between dark matter and ordinary matter, perhaps? Or are we witnessing the limits of our current physics? Upcoming telescopes like the Nancy Grace Roman Space Telescope could settle the debate, mapping Andromeda's mass distribution with unprecedented precision. Until then, this galactic paradox keeps spinning, a reminder that even our closest cosmic neighbor still holds mysteries waiting to unravel. Whether the answer lies in invisible halos or rewritten laws, one thing's clear: the universe doesn't follow a script even for the galaxies we think we know best. 35th phenomenon, the cosmic microwave background's cold spot. Imagine the afterglow of the Big Bang not as a smooth, uniform canvas, but as a tapestry woven with tiny imperfections, each one whispering secrets about the universe's infancy. Most of these ripples are subtle, mere fractions of a degree in temperature, but one anomaly stands out like an icy thumbprint pressed against the warmth of creation. The cold spot, a vast, unexplained region in the cosmic microwave background CMB that's significantly colder than its surroundings. This cosmic chill isn't just a curiosity, it's a potential crack in our understanding of reality itself. Stretching nearly 2 billion light-years across, the cold spot was first detected by NASA WMAP satellite and later confirmed by the Planck mission. At first glance, it might seem like a statistical fluke. After all, random variations are expected in the CMB's texture, but the odds of a fluctuation this extreme occurring naturally. Less than 1 in 50,000. That's like rolling a die and getting the same number 100 times in a row. So what could cast such a profound shadow over the universe's oldest light? One leading theory points to a cosmic defect, a relic from the universe's violent birth, like a tangled knot in space-time left over from rapid expansion. These hypothetical structures, known as textures or domain walls, could distort the CMB's temperature by altering how light traveled through the early cosmos. Think of it as a wrinkle in the fabric of reality, leaving a faint but measurable imprint. Then there's the spine-tingling alternative. The cold spot might be evidence of a collision with another universe. If our cosmos isn't alone, if it's just one bubble in an infinite multiverse, then it's possible another universe brushed against ours long ago, transferring energy in a way that left this eerie cold patch behind. It's speculative, sure, but not impossible. The idea hinges on cosmic inflation theory, which suggests countless universes may have sprouted like bubbles in a boiling pot. Not everyone's convinced. Skeptics argue the cold spot might simply be a supervoid, an enormous, underdense region of space where fewer galaxies and less matter mean less gravitational pull, subtly cooling light passing through it. Yet even this explanation struggles to fully account for the anomaly's size and intensity. If it is a void, it's far larger than any structure models predict should exist. What makes this frozen enigma so compelling isn't just its mystery, it's what it represents. If the cold spot is a defect or a multiverse bruise, it's a direct glimpse into physics beyond our current grasp. New telescopes, like the Simons Observatory in Chile, are scrutinizing this region with sharper eyes, hunting for patterns that might confirm or debunk these wild possibilities. For now, the cold spot lingers a silent, freezing question mark stamped across the sky. Whether it's a relic of cosmic chaos, evidence of a parallel reality, or just a statistical oddity, one thing's certain: the universe loves keeping us guessing. And somewhere in that icy expanse, the answer might be waiting, frozen in time. Beyond the familiar orbits of Neptune and Pluto, where sunlight fades to a dim twilight, something massive may be lurking in the dark, something we've never seen. Astronomers call it Planet 9, a hypothetical world up to 10 times the mass of Earth, sculpting the orbits of distant icy bodies like an unseen puppeteer. The evidence: a cluster of Kuiper belt objects whipping around the Sun on bizarre, tilted paths, orbits so peculiar they shouldn't exist unless something huge is tugging at them. The search for this phantom planet reads like a cosmic detective story. In 2016, astronomers Konstantin Batygin and Mike Brown noticed that several far-flung objects shared uncanny orbital similarities, angles, and alignments that defied random chance. Statistically, the odds of this happening naturally were less than 1 in 15,000. The conclusion was startling. An undiscovered planet 500 times farther out than Earth must be herding them into these strange trajectories. Yet here's the twist, we still haven't spotted it. If Planet 9 exists, why has it eluded every telescope? The answer lies in its possible hiding place. At such extreme distances, sunlight is virtually non-existent, making the world nearly invisible to optical telescopes. Even its infrared signature would be faint, smothered by the icy void. Adding to the challenge, its orbit could take 20,000 years to complete, meaning it might currently be lurking in the darkest, slowest part of its path. Skeptics argue these odd orbits might have other explanations, perhaps gravitational echoes from a long-ago stellar flyby, or the collective pull of smaller, unseen objects. But Planet 9's proponents counter with another clue. The Kuiper Belt's abrupt edge, known as the Kuiper Cliff, aligns eerily well with simulations of a massive outer planet's influence. Without it, the belt should taper off gradually, not plummet into nothingness like a cosmic drop-off. The hunt is far from over. Next-generation instruments like the Vera Rubin Observatory, with its unprecedented wide-field view, could finally catch this ghostly world's faint glimmer. And if confirmed, Planet 9 wouldn't just be another icy dwarf, it would rewrite our solar system's history. Was it a rogue planet captured by the sun's gravity, a primordial giant flung outward during the chaos of planetary formation, or something even stranger? For now, this potential titan remains hidden in the shadows, a silent reminder that even in our own cosmic backyard, the most monumental discoveries might still be waiting just out of sight. Whether myth or reality, Planet 9 challenges us to keep looking because the universe never runs out of surprises. 37th phenomenon, the Galactic Barrier at the edge of our solar system, where the sun's influence wanes and interstellar space begins. Something strange stands guard, an invisible wall that shouldn't exist. When the Voyager probes, humanity's farthest-flung emissaries, crossed this threshold, their instruments picked up an eerie signal, a sudden spike in particle density, as if the spacecraft had brushed against an unseen force field. Scientists call it the Galactic Barrier, and to this day, no one fully understands why it's there. This cosmic checkpoint sits roughly where the solar wind, a stream of charged particles from the sun, collides with the interstellar medium, the thin gas and dust filling the void between stars. Normally, this boundary should be a gradual fade, like waves dissolving into the open ocean. Instead, Voyager's data revealed a sharp, unexpected increase in cosmic rays, almost as if the probes had hit an invisible fence. Some researchers compare it to the heliopause, the solar system's magnetic bubble, but the Galactic Barrier behaves differently, more like a turbulent zone where interstellar and solar forces clash violently. So what's really going on? One leading theory suggests tangled magnetic fields woven by the Milky Way itself might be piling up at this frontier, creating a kind of particle dam. Another idea points to stellar winds from nearby stars pressing against our solar system and compressing this boundary into a denser, more defined wall. Then there's the more speculative notion, could this barrier be evidence of something larger, a structural feature of the galaxy that influences how star systems interact with the surrounding cosmos? But the mystery deepens when we consider timing. Voyager 1 crossed the barrier in 2012, while Voyager 2 followed in 2018, yet their readings didn't match perfectly. The second probe encountered a slightly thicker, more complex version of the barrier, hinting that this structure might shift over time, reshaping itself like a living boundary. What makes this discovery so captivating isn't just the science, it's the symbolism. For centuries, humans have imagined edges to their world, from mythical ocean cliffs to the boundaries of known space. Now we've found one that's real, a subtle but stubborn limit marking where our star's dominion ends and the great unknown begins. Future missions like NASA's Interstellar Probe aim to study this region in greater detail, peeling back the layers of this cosmic curtain. Until then, the Galactic Barrier remains a silent sentinel, a reminder that even as we reach into the void, the universe still has fences we've yet to climb. 38th phenomenon, the impossible quasar at the edge of the observable universe where time itself stretches thin. Astronomers have uncovered a cosmic paradox, a beacon of light so ancient, so impossibly massive, that it threatens to rewrite the story of how the universe grew up. Meet Euler's J 1342 plus 0928. A quasar blazing with the fury of a supermassive black hole 800 million times the mass of our Sun. But here's the catch. This cosmic monster existed when the universe was just 690 million years old, a mere toddler by cosmic standards. According to everything we know about black hole growth, this thing shouldn't exist, at least not yet. Quasars are the universe's ultimate powerhouses, supermassive black holes feasting on gas and stars, heating their meals to millions of degrees until they glow brighter than entire galaxies. Normally, such titans take billions of years to form, slowly bulking up through mergers and relentless feeding. But Euler's J 1342 plus 0928 defies the timeline. It's like finding a skyscraper in the ruins of an ancient civilization that hadn't even invented the wheel. So how did this black hole grow so big so fast? One theory suggests direct collapse, black holes, primordial behemoths born not from dying stars, but from the catastrophic collapse of vast gas clouds in the early universe. Picture a cosmic shortcut. Instead of starting small and eating its way up, this black hole could have formed already massive, a ready-made giant striding onto the cosmic stage. Others speculate that early black holes might have fed at impossible rates, gorging on dense gas flows with an efficiency we've never witnessed in the modern cosmos. But even these explanations strain credibility. The universe's first stars, known as population Roman III stars, were supposed to seed the earliest black holes, yet they wouldn't have had time to live, die, and leave behind cores large enough to grow into Euler's J 1342 plus 0928 staggering mass. Some researchers wonder if we're missing a piece of physics, perhaps a hidden law that allowed black holes in the infant cosmos to balloon unnaturally fast. Adding to the intrigue, this quasar's light reveals another shock. The universe around it was already partially transparent, meaning some cosmic reionization. The process that cleared the primordial fog had already begun. That suggests stars and galaxies were forming even earlier than we'd thought, pushing back the timeline of cosmic dawn. Every new observation of Euler's J 1342 plus 0928 peels back another layer of mystery. Future telescopes like the Nancy Grace Roman Space Telescope aim to hunt for even earlier quasars, testing whether this one is a freak outlier or evidence of a wholesale revision to cosmic history. For now, this impossible quasar stands as a luminous riddle, a flare from the universe's childhood that refuses to fit our textbooks. Whether it's proof of exotic physics or just the first of many cosmic anomalies waiting to be uncovered, one thing's certain: the early universe was far more dynamic, far more unpredictable than we ever imagined. And somewhere in that ancient light, the truth is glowing bright enough to blind us, if only we know how to look. 39th phenomenon. The triple star exoplanet. Most planets orbit a single star like Earth, basking in the steady glow of our Sun. But imagine a world where 3 suns rise and set in a never-ending celestial ballet, casting tangled shadows and shifting the very definition of seasons. These aren't sci-fi fantasies, they're real. astronomers have discovered exoplanets thriving in the gravitational chaos of triple-star systems, environments so turbulent they should, by all rights, tear fledgling worlds apart before they even form. Take Kelt 4ab, a gas giant locked in a cosmic dance with 3 stellar partners. The planet circles one star closely, while the other 2 twirl around each other farther out, lighting up the sky like a pair of relentless, dueling lanterns. It's a gravitational minefield, a place where competing pulls should destabilize orbits, flinging planets into the void. Yet somehow, Kelt 4ab endures. The mystery lies in how these planets survive their birth. Traditional models suggest planets form in calm, dusty disks around single stars, but in a triple-star system, fierce stellar winds and shifting gravity would shred these disks long before planets could coalesce. Unless, of course, nature has found a workaround. Some researchers propose these worlds might form quickly, clumping together at breakneck speed before their chaotic surroundings can rip them apart. Others think they could be cosmic migrants, born around a single star before getting captured by a binary or triple system later on. Even wilder, some triple-star planets might defy orbits entirely. In GW Orionis, a young system with 3 stars and a twisted protoplanetary disk, astronomers found gaps hinting at a planet forming outside the plane of the star's orbits, a place no planet should logically exist. If confirmed, it would mean some worlds carve their own paths, bending the rules of gravity to their will. What makes these discoveries so thrilling isn't just their defiance of expectations, it's what they reveal about cosmic adaptability. If planets can form and persist in such extreme environments, our universe might be far more inventive and far more hospitable than we ever imagined. Future telescopes like the James Webb Space Telescope will probe these chaotic systems in infrared, searching for hidden worlds and clues to their improbable survival. Whether flukes of physics or pioneers of untested formation theories, triple-star planets stand as cosmic rebels, proof that when it comes to building worlds, the universe doesn't always follow the blueprint. And somewhere in those tangled orbits, the next great planetary mystery might be waiting. 40th phenomenon, the cosmic ray hotspot deep in the constellation Ursa Major, where the night sky seems unremarkable at first glance, an invisible tempest is raging. Here, from an apparently empty patch of space, the universe is hurling subatomic bullets at Earth, cosmic rays packed with so much energy, they outstrip anything our most powerful particle accelerators can produce. But the real shock, these ultra-high-energy particles shouldn't exist, and we have no idea what's launching them. Dubbed the Cosmic Ray Hotspot, this enigmatic region was first detected by the Pierre Auger Observatory, a sprawling array of detectors in Argentina designed to catch the faint, cascading showers of particles created when cosmic rays slam into Earth's atmosphere. The data painted a startling picture, an excess of these ultra-rare, high-energy rays all streaming from the same general direction, a patch of sky conspicuously devoid of obvious cosmic powerhouses like active galaxies or supernova remnants. Normally, particles this energetic trace back to extreme environments, supermassive black holes guzzling matter, colliding neutron stars or monstrous stellar explosions. Yet the hotspot points toward a cosmic desert, a region where no known astrophysical engines should exist. So what's flinging these particles across the universe with the force of a major league fastball? One theory suggests we might be seeing the fingerprints of supermassive black holes hidden just beyond our vision. Perhaps one lurks behind thick dust clouds, its jets of accelerated particles redirected by magnetic fields we can't yet map. Alternatively, the rays could originate from galactic filaments, vast, magnetized highways of gas connecting galaxy clusters where shockwaves might boost particles to absurd energies. But the wildest possibility, these particles could be signals from decaying dark matter, If certain hypothetical dark matter particles, like WIMP or sterile neutrinos, were to spontaneously disintegrate, they might unleash bursts of energy capable of creating ultra-high-energy cosmic rays. It's a long shot, but if confirmed, it would be the first tangible clue to dark matter's true nature. Yet for all these tantalizing ideas, the hotspot remains stubbornly unexplained. Compounding the mystery, these cosmic rays don't travel in straight lines. Their paths bend as they traverse interstellar magnetic fields, making it nearly impossible to pinpoint their exact source. Some researchers argue the entire anomaly could be a statistical illusion, a chance alignment of random high-energy events. But with odds of that being less than 1 in 1,000, the cosmos seems to be hinting at something far deeper. New observatories like the upcoming Cherenkov Telescope Array aim to trace these particles with unprecedented precision, peeling back the layers of this high-energy whodunit. Whether the answer lies in hidden black holes, exotic physics, or something beyond our current imagination, one thing's certain: the universe is still firing mysteries at us, one cosmic ray at a time. And somewhere in that invisible storm, the next great revelation might be waiting, charged with enough energy to shatter our understanding of the skies. 41st phenomenon: the phantom galaxies. Missing dark matter galaxies aren't supposed to survive without dark matter. It's the invisible glue holding them together, the unseen hand shaping their rotation and structure. Yet in the cosmic wilderness, NGC 1052 DF4 drifts like a ghost ship, defying the rules. This ethereal galaxy, nearly transparent and eerily dim, appears to be missing all of its dark matter, a discovery so baffling it's forcing astronomers to question whether we've misunderstood the universe's hidden scaffolding. At first glance, DF4 seems unremarkable, a smudge of stars so diffuse you could peer straight through it. But when researchers measured its gravitational pull, the numbers didn't add up. Normally, a galaxy's visible stars account for just a fraction of its mass. The rest is dark matter, holding everything in place. Here, the stars move exactly as predicted by the gravity of visible matter alone, as if the dark matter simply never showed up. The implications are staggering. If DF4 truly lacks dark matter, it shouldn't exist in its current form. Without that gravitational anchor, the galaxy's sparse stars should have scattered into the void long ago, torn apart by tidal forces or simple cosmic drift. So how did this phantom endure? One theory suggests DF4 might be a tidal remnant, a galaxy stripped of its dark matter by a violent encounter with a larger neighbor, like NGC 1052. Picture a cosmic thief sneaking in, stealing the invisible mass and leaving behind a skeletal trail of stars. Yet even this explanation feels incomplete. Simulations show such encounters would likely shred the galaxy entirely, not leave it floating intact. Then there's the radical alternative: dark matter might not be universal. Could certain galaxies form through entirely different processes, bypassing the need for this mysterious substance? If so, DF4 and its kin, like the similarly puzzling NGC 1052 DF2, might represent a new class of celestial objects, born under conditions we've yet to imagine. Skeptics, of course, argue the measurements could be flawed. Maybe DF4 dark matter is hiding in a form we can't detect, or perhaps its stars are arranged in a way that mimics a dark matter-free system. But with each new observation, the anomaly grows harder to dismiss. What makes this phantom galaxy so electrifying isn't just the mystery, it's the way it turns cosmology's assumptions inside out. If dark matter isn't always mandatory, what other cosmic rules might have exceptions? Upcoming telescopes like the James Webb Space Telescope are poised to scrutinize DF4's delicate structure, hunting for clues in its faint starlight. For now, this celestial enigma floats in silence, a reminder that even the universe's most trusted blueprints might still have missing pieces. and somewhere in its ghostly glow, the next great cosmic revelation could be hiding, waiting for us to look closer. 42nd phenomenon. The moon swirls. The moon's surface isn't just a lifeless expanse of gray dust, it's a gallery of cosmic art. Etched across its plains are ghostly, swirling patterns like cream stirred into coffee or ink spilled across parchment. These delicate formations, known as lunar swirls, stretch for miles in elegant, looping curls, their bright tendrils standing in stark contrast to the darker regolith around them. But here's the twist: these aren't random brushstrokes. They're locked in place by an invisible hand, defying erosion for billions of years. And the deeper we look, the stranger the mystery becomes. At first glance, the swirls seem almost decorative, pure coincidence etched by solar winds or ancient impacts. Yet when scientists mapped them against the moon's weak magnetic fields, an eerie pattern emerged. The brightest swirls align almost perfectly with patches of localized magnetism. It's as if some unseen force field has shielded these regions, preserving their brightness while the surrounding terrain darkens under relentless bombardment from space. But how? The moon's magnetic fields are far too feeble to deflect solar radiation on their own, let alone sculpt such intricate designs. One theory suggests these swirls might be relics of cometary impact. When icy comets slammed into the lunar surface, their volatile materials could have interacted with the soil, creating temporary magnetic bubbles that altered how sunlight reflects off the terrain. Another idea points to lava tubes, ancient volcanic features that might have once channeled molten rock, leaving behind mineral deposits that generate localized magnetism. Then there's the wild card. Could the swirls be evidence of past lunar volcanism interacting with a now extinct dynamo, imprinting these patterns like cosmic fossils? But the real puzzle isn't just their origin, it's their endurance. Solar wind and micrometeorite impacts should have erased these delicate features long ago. Yet they persist, pristine and untouched, as if the moon itself is guarding them. Some researchers suspect the magnetism might be deflecting charged particles, acting like an invisible umbrella that slows erosion. Others wonder if electrostatic forces or even underground anomalies play a role, anchoring these patterns in place against the relentless grind of time. The intrigue doesn't stop there. Similar swirls appear on other airless worlds like Mercury, hinting that this phenomenon might be a universal signature of magnetic mysteries. Upcoming missions like NAS, a lunar vertex rover, aim to study these swirls up close, probing their magnetic fields and mineral composition. What they find could rewrite not just our understanding of the moon's history, but how celestial bodies across the cosmos wear their scars. For now, these silent spirals remain one of the solar system's most hypnotic riddles. Whether born from cataclysmic impacts, hidden geology, or forces we've yet to imagine, they're a reminder that even the nearest worlds keep secrets etched in light and shadow, waiting for us to decipher their code. 43rd phenomenon, the impossible supernova. Most supernovas flare and fade within months, spectacular but predictable finales to a star's life. Then there's SN 2016 IAT, a cosmic explosion so bizarre it seemed to break every rule in the book. This wasn't just a dying star's swan song. It was a performance that dragged on for years, defying expectations with every flicker. And when scientists finally pieced together its strange behavior, they realized they might be staring at a type of stellar death so rare it's never been seen before. The anomalies started piling up immediately. Unlike typical supernovas, which peak in brightness within weeks, SN 2016 IAT burned sluggishly for over 1,000 days, as if the star couldn't decide whether to die. Even stranger, its light curve, the fingerprint of its explosion, lacked the radioactive isotopes that usually power such events, like nickel-56. It was like a fireworks show without gunpowder. No one could figure out what was fueling it. Then came the real shocker. The star that birthed this supernova was a loner. Most massive stars live in dense stellar neighborhoods, but this one floated in isolation, far from the gas-rich regions where supernovas typically occur. That isolation raised a glaring question: how could a star this massive, possibly 130 to 260 times the Sun's weight, form all by itself? The leading suspect is a pair instability supernova, a theoretical explosion so violent it vaporizes the entire star, leaving no black hole or neutron star behind. These occur when a star's core gets so hot that light itself starts spawning particle pairs, destabilizing the core and triggering a runaway thermonuclear implosion. The problem, even that doesn't fully explain SN 2016 IAT's marathon decay or its missing chemistry. Some researchers suggest an even wilder possibility, that this might be the first observed pulsational pair instability supernova, where the star undergoes multiple violent eruptions before its final collapse. Others wonder if it was a collision, two massive stars merging in a cataclysm that defies conventional models. What makes this supernova so groundbreaking isn't just its defiance of categories, it's the way it forces us to rethink stellar life cycles. If stars can die like this, how many other explosion types are we missing? Upcoming surveys, like those from the Vera Rubin Observatory, will scan the skies for similar oddities, hunting for clues in the wreckage of other impossible stars. For now, SN 2016 IAT stands as a luminous mystery, a cosmic outlier that refuses to fit the mold. Whether it's a rare fluke or a sign of hidden physics, one thing's clear: the universe still has explosive surprises up its sleeve. And sometimes the most important discoveries don't just fade away, they linger, demanding we rewrite the rules. 44th phenomenon. The dark galaxy, the universe's unlit shadow. The cosmos loves its fireworks, galaxies ablaze with stars, nebulae glowing like celestial stained glass. But sometimes the universe leaves a canvas almost untouched, floating in the void like a phantom. J0613+52 defies the usual cosmic spectacle. This isn't just another dim galaxy, it's a vast, swirling reservoir of gas, rich with the raw materials to birth countless stars, yet eerily, stubbornly dark. No stellar nurseries, no glittering spiral arms, just a silent, starless expanse drifting like an unfinished symphony. Discovered almost by accident during a radio survey, this dark galaxy is a cosmic paradox. Its hydrogen gas weighs as much as a small galaxy, yet scans reveal barely a flicker of starlight. It's as if nature gathered the ingredients for a feast, then forgot to light the stove. So why didn't this cosmic loner ignite? One possibility is solitude. Unlike most galaxies, J0613+52 appears utterly isolated, no neighbors to jostle its gas clouds, no gravitational nudges to trigger star formation. In the crowded cosmic metropolis, this might be a hermit, its gas too diffuse and undisturbed to clump into stars. Think of it like a cloud floating high in Earth's atmosphere, too thin to rain, too calm to gather into storms. Yet there's a twist: the galaxy's gas isn't entirely pristine. Deep radio observations reveal faint ripples and eddies, hints of turbulence that should have sparked at least some stars. Unless, of course, something is actively suppressing them. Some theorists suggest powerful magnetic fields might be strangling star birth, preventing gas from collapsing. Others wonder if dark matter, usually the unseen architect of galaxy formation, might be distributed here in an unusual way, its gravitational grip too weak to pull the gas together. But the most tantalizing clue lies in what J0613+52 could represent: a living fossil from the universe's youth. Before the first stars blazed, the cosmos might have been dotted with similar dark galaxies, primordial gas clouds waiting for the right conditions to awaken. If true, this cosmic shadow could be a rare time capsule, preserving a state most galaxies outgrew billions of years ago. The mystery isn't just academic. If dark galaxies are more common than we've realized, they could be hiding vast reservoirs of missing ordinary matter, invisible to telescopes yet woven into the fabric of the universe. New radio arrays like the Square Kilometre Array aim to sweep the skies for more of these phantoms, testing whether J0613+52 is a cosmic fluke or a sign we've been overlooking an entire population of ghosts. For now, this starless enigma drifts in silence, a reminder that even in a universe aflame with light, darkness still has stories to tell. And somewhere in that uncharted void, the next chapter of galactic evolution might be waiting, written in gas and shadow if only we know how to look. 45th phenomenon. The rogue supermassive black hole. Picture the most powerful force in the universe, a supermassive black hole. The gravitational heart of a galaxy suddenly hurled into the void like a cosmic cannonball. This isn't science fiction. Astronomers have spotted a runaway black hole, a monolith of pure gravity barreling through intergalactic space at millions of miles per hour, trailing a wake of shocked stars and gas like a ship plowing through celestial waters. And the question isn't just how but what kind of violence could tear a black hole from its throne. The leading theory is as dramatic as the event itself, a three-body gravitational duel. When galaxies collide, their central black holes spiral toward each other, locked in a dance that can last eons. But if a third black hole joins the fray, the chaos can catapult one of them into the abyss. Picture a game of cosmic pinball where the loser gets flung out at speeds that defy imagination, no longer the anchor of a galaxy but a lone wanderer in the dark. Yet even this explanation raises eyebrows. The energy required to eject something billions of times the sun's mass is staggering. Some simulations suggest the kick comes from asymmetrical gravitational waves, ripples in spacetime that blast outward during the black hole's final merger, acting like a rocket's uneven exhaust. If those waves shoot off more powerfully in one direction, the recoil could send the remaining black hole flying, but the rogue's journey doesn't end there. As it plows through intergalactic gas, it may leave behind clues, a trail of newborn stars ignited by the shock of its passage. Some astronomers argue these stellar streaks could be the only way to track these invisible exiles like breadcrumbs left in the dark. What makes this phenomenon so gripping isn't just the scale of destruction, it's the defiance of our expectations. Black holes are supposed to lurk, not roam. Their discovery forces us to reconsider how galaxies evolve, and whether our own Milky Way might one day suffer a similar upheaval, with telescopes like Hubble and JWST now scanning the skies for more of these renegades. Each sighting peels back another layer of the mystery. Because in a universe ruled by gravity, even the mightiest monsters aren't always where they're supposed to be. 46th phenomenon. The impossible star in a universe littered with the ashes of dead stars, where supernova have scattered heavy elements like cosmic graffiti for billions of years. One ancient survivor stands apart, a celestial time capsule so pristine it shouldn't exist. Meet SDSS J102,915 plus 172,927. A star so chemically pure it's like finding a drop of rainwater untouched by pollution in the middle of an industrial wasteland. Made almost entirely of hydrogen and helium with barely a trace of heavier elements, this relic is the closest thing we've found to a star from the dawn of time. The puzzle isn't just its composition, it's how it endured. After generations of stars lived, died, and seeded the cosmos with metals, what astronomers call all elements heavier than helium, virtually every star since has carried their fingerprints. Even the Sun contains traces of iron, carbon, and oxygen forged in long-dead stellar furnaces. but SDSS-J 102,915 plus 172,927 defies that legacy. Its metallicity, the measure of these heavier elements, is 20,000 times lower than the Sun's. That's like comparing a glass of distilled water to the entire Pacific Ocean. So how did this primordial holdout escape contamination? The leading theory suggests it formed from a pocket of gas so untouched, so isolated, that it bypassed the chemical enrichment of later stellar generations. Picture a tiny bubble of the early universe, a place where the first clouds of hydrogen and helium somehow avoided being polluted by nearby supernova, preserving their purity like a cosmic time capsule. But even that explanation strains credulity. Current models of star formation insist that without at least some heavier elements, gas clouds can't cool and collapse efficiently enough to ignite a star. Yet here it is, shining defiantly in the constellation Leo, mocking our assumptions. Some researchers speculate that SDSS-J 102,915 plus 172,927 might be a rare survivor from an alternate path of star birth, one where turbulence or magnetic fields in the early universe allowed stars to form under conditions we've never replicated in simulations. Others wonder if it was born in an unusually quiet corner of space, far from the violent stellar nurseries that churned out heavier elements, but the most tantalizing possibility. There could be more stars like it hiding in the shadows, fossils from a time before the universe learned to forge metals, waiting to be discovered. Telescopes like the James Webb Space Telescope are now scanning the skies for similar rarities, hunting for clues in their faint light. What makes this star so extraordinary isn't just its defiance of physics, it's the window it offers into a lost era. Every other star we've studied tells the story of cosmic evolution. This one whispers secrets from before the story even began. And in that whisper, we might finally hear how the first sparks of light ignited in the darkness. 47th phenomenon. The giant in the shadows Kepler 1625b's impossible moon. Our solar system's moons are a motley crew, icy worlds, volcanic hellscapes, even a few that might harbor life. But lurking in the data from a distant star system, astronomers may have stumbled upon something that dwarfs them all. Kepler 1625b, a moon so colossal it defies every rule about how satellites form. If real, this candidate exomoon wouldn't just break records, it would shatter our understanding of planetary systems entirely. Here's the jaw-dropper. This potential moon is roughly the size of Neptune, orbiting a planet nearly as massive as Jupiter. That's like finding a beach ball tethered to a basketball, a scale so extreme. Theorists struggle to explain how such a pairing could even exist. The discovery sent shockwaves through astronomy, not just because of its size, but because it hints at a universe where moons might roam in sizes we've never dared imagine. The evidence comes from subtle, telltale dips in starlight. When the planet Kepler 1625b transited its star, Hubble Space Telescope data revealed a second, smaller dimming after the planet passed, as if something trailing the planet briefly blocked the star's glow. The timing and shape of that flicker matched what you'd expect from a moon, but the numbers didn't. For a moon to cause that signal, it would need to be a behemoth, far larger than any moon-forming model predicts. Skeptics argue it could all be a cosmic mirage, perhaps a second planet in the system mimicking a moon signal, or even a glitch in Hubble's sensitive instruments. But proponents counter with an even wilder possibility. Maybe this isn't a moon at all, but a captured world. Imagine a scenario where Kepler 1625b's gravity snatched a rogue planet drifting through space, forcing it into permanent servitude as a satellite. It wouldn't be the first time celestial theft reshaped a system. Neptune's moon Triton is likely a captured Kuiper belt object, but never on this scale. Yet the mystery runs deeper. If giant exomoons are common, why haven't we found more? Current telescopes can barely detect such faint signals, leaving us to wonder if Kepler 1625b I is a freak outlier or the first of many waiting in the shadows. New observatories like the James Webb Space Telescope could finally settle the debate, peering into the atmospheres of distant moons and hunting for chemical traces that betray their presence. For now, this potential megamoon hangs in limbo, half discovery, half enigma. Whether it's a data quirk or a cosmic game-changer, one thing's certain: the universe loves testing the limits of what we call possible. And somewhere out there, in the flicker of distant starlight, the truth still orbits just beyond our grasp. 48th phenomenon: the cosmic radio circles deep in the static of the universe's radio whispers. Astronomers have stumbled upon something that defies logic: vast, ghostly rings hanging in space like echoes of a sound no one heard. These cosmic radio circles, CRC, stretch hundreds of thousands of light years across, yet they emit no visible light, no X-rays, just faint, looping radio waves that materialize in deep sky surveys before fading into the background. They're not supernova remnants, not distant galaxies. So what exactly is painting these invisible titans onto the cosmos? The discovery came as a shock. While combing through data from the Australian Square Kilometre Array Pathfinder ASCAP, researchers spotted these eerie rings lurking in the radio spectrum, perfectly circular yet utterly disconnected from any known object. Unlike planetary nebulas or Einstein rings, which have clear central sources, the CRCs float in isolation. No black hole, no galaxy cluster, no cataclysmic event to explain their existence. It's as if the universe pressed a giant, unseen stamp onto the sky. One leading theory suggests these could be shockwaves from black hole mergers, colossal ripples in the interstellar medium triggered by two supermassive black holes spiraling into each other. When these giants collide, they unleash energy equivalent to billions of supernovas, potentially sending out spherical waves that glow faintly in radio frequencies as they expand. But there's a catch: no black hole pairs have been found near the circles, and the timing doesn't quite fit. These rings are too perfectly round, too symmetrical, as if the shockwave hit a previously unseen wall of gas and froze in place. Another idea points to orphaned lobes from ancient radio galaxies. Most active galaxies shoot out twin jets of particles that form giant radio lobes on either side. Over time, if the galaxy's core shuts down, those lobes could detach and drift, morphing into ring-like structures as they dissipate. Yet even this explanation falls short. The circles lack the telltale distortions or trailing debris you'd expect from such a process. Then there's the truly radical notion: something entirely new. Could these rings be relics of an unknown astrophysical phenomenon, perhaps a phase transition in the early universe's magnetic fields, or the imprint of cosmic strings vibrating through space-time? Some theorists even float the idea of dark matter annihilation, where hypothetical particles collide and release bursts of energy in perfect spheres. The deeper astronomers look, the stranger the mystery becomes. Recent observations with the Mercator Radio Telescope reveal that some circles have faint, filamentary structures inside them, like veins in a leaf, hinting at turbulent magnetic fields or shock fronts frozen in time. Others seem to evolve over years, expanding or fading in ways that defy simple explanations. What makes these radio circles so electrifying isn't just their mystery. It's the way they force us to confront how much of the universe's activity might be happening in wavelengths we've barely begun to explore. Upcoming projects like the Square Kilometre Array SCAR will scan the skies with unprecedented sensitivity, hunting for more of these spectral fingerprints. And as we peel back the layers of this enigma, one thing's certain: the cosmos has a habit of revealing its secrets in the quietest signals, if only we learn how to listen. From black hole echoes to phantom physics, every new discovery peels back another layer of the cosmic unknown. And somewhere in those silent loops of radio light, the next great astronomical revolution might already be written, invisible for now but waiting to be heard. 49th phenomenon. The hypervelocity stars. Most stars move with the stately grace of dancers in a galactic ballet, orbiting the Milky Way's center in predictable, looping rhythms. Then there are the outliers, the cosmic renegades hurtling through space at speeds so blistering, they're destined to flee the galaxy entirely. These hypervelocity stars don't just wander off, they sprint, ejected from their celestial neighborhoods with enough force to defy gravity itself. And the culprit behind their dramatic exit, a gravitational slingshot so violent it could only come from one source, a supermassive black hole. The first of these stellar speedsters was discovered in 2005, a lone blue giant racing outward at over 1.5 million miles per hour, fast enough to cross the distance from Earth to the Moon in just 14 minutes. Since then, astronomers have catalogued dozens more, each tracing a path back to the galactic center like cosmic breadcrumbs leading to a scene of celestial crime. The math is undeniable. To achieve such velocities, these stars must have been flung outward by the titanic gravity of Sagittarius A, the Milky Way's central black hole, during a cataclysmic encounter millions of years ago. But how does a black hole launch stars like celestial cannonballs? The leading theory involves a cosmic game of gravitational pinball. Picture a binary star system, two stars orbiting each other, venturing too close to the black hole's event horizon. As the black hole's tidal forces rip the pair apart, one star gets captured, spiraling inward to its doom, while the other is hurled outward at unimaginable speed, a survivor of celestial chaos. It's a brutal exchange, one star sacrificed to send its partner flying into the void. Not all hypervelocity stars fit this mold, though. Some appear too old or too lightweight to have survived such a violent ejection, hinting at alternative origins. Could supernova explosions in tight star clusters have kicked these travelers into the galactic fast lane? Or might they be intergalactic interlopers, hurled our way by collisions with dwarf galaxies or dark matter subhalos? The diversity of these stellar fugitives suggests the cosmos has more than one way to fling a star into exile. What makes these speedsters so fascinating isn't just their origin, it's their fate. Unlike most stars forever bound to the Milky Way, hypervelocity stars are destined to escape, crossing into the barren intergalactic void where no new stars shine. They're cosmic messages in bottles, carrying clues about the galaxy's turbulent past in their composition and trajectory. By studying their light, astronomers can reconstruct their birthplace, even estimating the timing of their explosive departure from the galactic core. Upcoming telescopes like the Nancy Grace Roman Space Telescope aim to hunt for more of these outliers, potentially uncovering hypervelocity planets or even rogue black holes ejected by similar mechanisms. Every new discovery peels back another layer of the galaxy's hidden violence, proof that even in the vast, seemingly serene cosmos, gravitational warfare is constantly reshaping the stellar landscape. So the next time you gaze at the night sky, remember, among the countless steady lights, there are a few streaking silently toward oblivion, their speed a silent testament to the black hole's ruthless power. And somewhere in their swift, lonely journeys, they carry the untold stories of the galaxy's most extreme encounters. 50th phenomenon. The universe's missing lithium. Picture the universe in its first frenetic minutes, an unimaginable forge where the raw ingredients of reality fused into the simplest elements. Hydrogen, helium, and a whisper of lithium were all forged in this primordial fire, leaving a fingerprint astronomers call Big Bang nucleosynthesis. The math behind these early moments is precise, even elegant, except for one glaring hiccup. When scientists tally up the lithium expected from those first chaotic seconds, the numbers don't match what we see today. A staggering 2/3 of this lightweight element is simply gone. This cosmic lithium deficit isn't just a minor accounting error. It's a full-blown mystery with implications stretching from the birth of stars to the fundamental laws of physics. Telescopes scanning ancient stellar atmospheres find far less lithium than the Big Bang's recipes predict, as if some unseen hand swept through the cosmos, erasing it from the ledger. So where did it all go? One leading theory points to the stars themselves. Over billions of years, lithium, a fragile element easily destroyed at high temperatures, might have been burned away in stellar cores. Imagine a cosmic recycling program where stars ingest lithium like kindling, leaving only ashes behind. Yet even this explanation falls short. While some lithium depletion happens in stars, models struggle to account for the sheer scale of the shortage. That's where things get even stranger. Some researchers propose that unknown particle interactions in the early universe could have zapped lithium before it ever had a chance to accumulate. Exotic physics, like hypothetical action like particles or variations in fundamental constants, might have altered the nuclear reactions that birthed these atoms. It's a radical idea that the universe's missing lithium could be a clue to forces beyond the standard model. Others suspect the answer lies in places we've barely begun to explore. Could lithium be hiding in the diffuse gas between galaxies, invisible to our telescopes? Or might it have settled into brown dwarfs, failed stars too cool to destroy it, lurking undetected in the cosmic shadows? The hunt for answers is far from over. New telescopes like the James Webb Space Telescope are peering into the atmospheres of the universe's oldest stars, searching for traces of lithium that could rewrite this elemental whodunit. Whether the solution points to stellar chemistry, undiscovered physics, or something even more unexpected, one thing's clear: in the grand story of the cosmos, even the smallest atoms can hold the biggest secrets. From the first moments of creation to the stars that light our sky, lithium's disappearing act reminds us that the universe's ledger is still missing pages. And somewhere in that gap between prediction and observation, the next great cosmic revelation might be waiting, written in the faintest spectral lines, if only we know how to read them. As we reach the edge of this cosmic journey, one truth becomes undeniable: the universe isn't just stranger than we imagine, it's stranger than we can imagine. From stars that flicker like malfunctioning streetlights to galaxies spinning without dark matter, every mystery we've explored is a humbling reminder. We've only just lifted the curtain on reality's grand stage. What ties these 50 enigmas together isn't just their defiance of our textbooks, it's the way they transform the unknown into an invitation. Each unexplained signal, each celestial oddity, is a cosmic breadcrumb, urging us to look deeper, question harder, and rethink what's possible. The wow signal's fleeting whisper, the Great Attractor's relentless pull, even Saturn's uncanny hexagon, they're not just puzzles, they're proof that discovery never truly ends. Technology will keep evolving, telescopes sharper, algorithms smarter, but the universe has a way of staying one step ahead. For every mystery solved, like the pioneer Anomaly's thermal explanation, another takes its place, like the Hubble Tension ripping at cosmology's seams. And that's the beauty of it. The cosmos isn't a riddle to be finished. It's an endless conversation, with each answer sparking 10 new questions. So what's next? Maybe you'll be the one spotting an anomaly in fresh telescope data, or perhaps the James Webb Space Telescope will uncover a phenomenon so bizarre it makes our current list look tame. That's the thrill of living in this golden age of exploration. The next great revelation could happen tomorrow. Before we close, we'd love to hear which mystery gripped you the most. Was it the chilling silence behind the Fermi Paradox, the eerie precision of Hoag's object? Drop your pick in the comments. We're just as curious as you are. And if you're hungry for more deep dives into the unexplained, hit subscribe. The universe has plenty more secrets to share, and we're just getting started. Until next time, keep your eyes on the skies and your mind open, because out there in the vast, uncharted dark, the next great wonder is already waiting.